I am the chief servant at the Kachi Group. We started as Kachi Company it was incorporated April 21, 1989. April 21, 2025 made us 36 years old. 36 years old. And in 36 years, what has kept us going is the fact that we understood who we are. We understand who we are. Ministry. Ministry to man, ministry to God. And we operate with a sense of excellence, the spirit of excellence, the spirit of God. So we look for excellence in everything we do. And that's why we're partnering with Thermo Fisher, because they stand for excellence. We partner with Merck because they're premium. I want to welcome you all. We have Happiness tried to do some of my work. I'm not going to do hers, but I want to welcome you. As the chief servant of the house, I should. You left very important things. There's so many CEOs, founding MDs of our captive segment of interest. Life sciences, in the research, in laboratory, in hospital, clinical. So welcome. You left very important things to come. We appreciate you. We know that we can partner with you. The reason for this thing we're doing here, is to begin to form close collaborations between science, the manufacturers of equipment, Thermo Fisher Scientific, the laboratories, we who supply them and we who also do the lab, the researchers in the university, in the NIMA, in the Institute of Research, the clinical, the hospital, Master Ruth is here, using the product of the equipment, the research and things to touch lives. So it's from the bench to the bedside is what we're trying to do. That ecosystem, that whole value chain is to make it work for the black people. Whatever works for Nigeria will work for Africans, will work for Brazilians, will work, and if you put us all together, all the black people on earth, we have a bigger economy than any of the blocks. So it's time to begin to take our lives in our hands and begin to do things. I'll tell you my passion of late, you get to a stage in life and you're no longer subsisting. I'm going to stand here and tell you that my husband feeds me. Tell him I said so. The house I live in, he builds and he maintains. The car I drive, he provides. The children on my neck, he pays for. So that's not the reason I work. The reason I work, the reason I wake up every day is to find solutions. We identify gaps and we bridge them. We started by equipping labs many years ago, 35, 36 years ago. And we got to the point where after Africa continental trade was happening, and there was no world-class accredited, internationally accredited laboratory in Nigeria that can certify products and that you cannot question their results, to enable our exporters to participate in this big block that's called Africa, that this trade group is about. We went to our partners, our manufacturing partners, to Thermo Fisher Scientific, to Merck, and we said to them, support us. To them, it's a demo lab. To us, it's an independent analytical lab. Our labs are internationally accredited, the only one this side of the Sahara. Yes. And we did that to enable farmers, exporters, to export without rejection. That's another story. And in the process, we identify the gap in genomics, in forensic, and we had already started, so we extended into it. We've just completed audit by ANAB, which is one of the top 2 accrediting bodies in the world, to certify our genomic forensic lab. So we're ready now, Professor Catherine being our consultant, to take on cancer samples, whether it be liquid or solid, to analyze and produce results. So you don't have to send those samples abroad. We don't have to send our biomaterials. There's a risk to it. We don't have to send, Biobank is here. We don't have to send our important materials out. It will also cost less, because the time, even if all we charge is the shipping cost, it will cost less. So we found that gap. Then I was talking to my sister Modupe, and she was telling me, oh, they're building their next big thing. I know all their monies are in place. I know some people who are, I'm most of them bragging about it, I can tell you that. And she said to me, if you can do this part of it in the pathology side, I don't have to do it in my place. And that's what collaboration is about. That we don't have to have little labs and little thing everywhere. If you can do it and you have the capacity and you can, aggregate and make it viable, do it, then somebody else is doing something else, and together we are all winning. Pathologists, right? So we identified that gap. Prof and I went to South Africa to look at other labs, pathology labs, to make sure we do it right, because we want to get it right the first time. We don't want to just dabble into things we don't know. We're finishing now. I don't know who is in Lagos State. They're delaying us. We should have gone live long before now, but for 2 months we have been trying to get permits to remodel, repurpose the building, but we have the equipment already for the pathology lab. So we're waiting on that, and yes, we'll have collaborations, cooperations, partnerships as we progress on that. And I know that happiness will eventually throw off light on these things. The first time I went to see the Minister of Health, and I printed a company profile, because we didn't have the time to project it, so I had it printed. He opens it, he said, nobody told me about this place. You mean a lab like this exists and they haven't told me? Why didn't they tell me? Are you able to do bioequivalence? I said, what is that? It says, does your lab do bioequivalence? No, we don't, because if I don't know it, we don't do it. And I came back and I went to my people and I said, hey, what does it take for us to begin to do bioequivalence? To extend the scope into that. That's finding gaps and filling it. And when we looked at ourselves, we had the space. Most of the equipment we have in the analytical lab are the equipment you need for bioequivalence. So you just organize the workflow and begin to do it. So we're also extending there. USP is helping us. So that's what we do, is identify gaps, and wherever we can, put together resources and close those gaps so that Africa, Nigeria can move ahead. Today, I want to challenge all of us in this room that will have a mindset of whether there's a government or there is no government, whether there is a leadership or no leadership, it's time to take our lives in our hands. It's time to begin to do the things wherever we are. People come into our lab and they can't believe it's private. Arrive Alive, right, is what they're called, was working with some government agencies and their labs, the big ones that they have big budgets. And World Bank, World Health Organization was wanting to train analysts on trans fat, in food. And they went around all those labs and they couldn't find one that could support them training the analysts across the country. And they approached us. We donated the lab for free. But that's where they came to train, because we have better quality, better equipment, better processes, better technique, and personnel in our lab than any other lab in the country, including those government labs that have a lot of budget that pass through them. So we do not need to sit and wait for government to do things for us. We need to get up and decide to take our lives in our hands. We need to know that our lives count. We need to know that when we're done, we are accountable to the one who gave us life, and we must answer for every breath we took on earth. I want you to leave this place knowing that you are responsible for finding solutions. Medicine has gotten too personalized. If you think that white people are going around trying to find solutions for you, you're joking. We have to find the solutions that will work for us. In the gym pool that they do their research around, you don't have significant Black representation in it. Welcome to Empowering Innovation in Life Sciences. I have to welcome you. It's your first time in Nigeria. It's Mausin's first time in Nigeria. And I have to say that it's around him that we decided to do this conference. So you do have to come back. We're going to go to Abuja next. We'll do something similar in Abuja as well. But you believe in this nation, you believe in what is possible. They told you, it's not safe to come. You had to jump through hoops to get approval from Thermo Fisher Scientific to be able to come. And I want everybody in this room to celebrate this woman. She came up with brilliant ideas. incredible. I mean, she says this is what we need to do. I say exactly, amazing, incredible. And she pulled this thing single-handedly. Next time, let's have a committee and let more people help you so you're not stretched out and burnt out, but you've done an amazing work. With that, I hand it over.
And I want to say thank you to you guys, because if you didn't come, if you didn't come, but you did, we feel honored. We feel that, I know pulling this caliber of persons is not easy, but I'm happy it has been done. And but you need to know a little bit about Kachi. In an institution that is setting up, we are here for you. That's why we called you today, to tell you that we can handle that issue for you. Now, over the past 3 decades, I will correct that and say, close to 4 decades, Kachi has supported and developed the development of science in Nigeria. We've been doing this with reagents, equipment, consumables, everything you need. Next slide, please. Our vision, to be the complete source, everything. We enter a place, we close the door. We say, we can solve your problem. So we've been doing, this is our vision. And we want to equip science with quality products. That's why we have ISO certification. And we are proud to ensure that it is updated, that no issues. At every point in time, we have our certification there, which is our processes. It's not just a paper. It's our processes. Quality, we ensure our processes are managed right. Now, and Kachi's corporate magazine is zero defect. Now, I know one or two, there might be 1 or 2 issues here and there, but we will ensure that at the end of the day, it is resolved. Now, that is our zero defect, zero error. Next slide, please. Our partners. Okay, our CEO spoke about some, but today we are here to celebrate Thermo Fisher Scientific. So, I'll just speak. We have partners. Thermo Fisher Scientific is central in the partnership. This is, next slide please. This is how we are able to serve this sector. Please, I don't know if you can locate your sector in this slide. Please look up. Locate your sector. If it's not there, please speak to me at the outside so that we will come to you, because you are missing out. So we will come to you. It's a serious, we can handle whichever. Pharma, oil and gas, medical, manufacturing, educational, regulatory, research. Next slide. We are doing business all over. We are serving them with whatever needs they have. Now, our partnership with Thermo Fisher is celebrated. This table, Prof. I have made you Thermo Fisher. Catch it. This table, inclusive of Prof, is from Thermo Fisher. So they are going to speak to us, technical sessions, where they are going to tell us what their offerings are. Please, I know we started a bit late, but please, stay here, you'll be glad you did. Okay, laboratory equipment as accessories, STEM, lab design and benching, chemicals and reagents, glasswares, consumables. We are all training, and we just finished a training session with Footmina. They came to have their lab technologists trained. So we did one with Teflon not too long ago. So we can train your staff on any instrument we have in our warehouse. And if we don't have it, we can discuss about it. Next slide, please. Okay, chemicals, solvents, salt, buffer, stains, kits. These are products we serve Nigerian labs with. Equipment, HPLC, no, next slide. HPLC, FTIR, AAS. I want to invite you to our lab. We have a tour of the lab after now. You will see all this in the lab. And I don't think there is any lab that has the array of laboratory equipment that we do have. Some of us have been to the lab. I saw somebody doing like this. He said, I concur. Yeah? I agree. So these are some of the genetic analyzer. Now, I told you earlier, We can build the lab for you. So we do benching. We can set up the lab. You need laboratory benching. This was done. This is Kachi Analytical Lab, equipped, designed, and installed by Kachi. Everything. You will see the lab. And I'm telling you, you'll be glad you came. Now, this is Crown Flower Quality Bill. We designed this. Unilag Research Lab. We designed this. Dangote Quality Control Lab. Let's move. TEDFund training. Just to show you what we've been doing. I have 15 minutes, please. So that we can move. Now, these are some of the customers we have in Nigeria. IITA, Dangote, University of Lagos, Chevron. Next. Now, I will speak about this. No, don't move it. Vendor managed inventory, because there might be somebody or an institution that needs this. Now, what we are saying basically is that we can help you warehouse your agents so that it is not caught up with exchange rates, and maybe you don't even have the space for stocking. So we can help you warehouse. Now, if you know you will use 5 or 6 units of an item, we can help you warehouse it so that at the same price. So that when you are calling for it, you are calling for something, maybe you place the order in January. We are no more Kachi company. We are the Kachi Group. Thank you. Thank you for remembering. Now, Kachi Lab. To become Africa's #1 independent analytical laboratory complex by partnering with global experts and chemical manufacturers to deliver world-class results. And to provide, our mission is to provide relying our tests here, having our results here, because of a whole lot of other factors. We've started doing it. And that is why we are saying we are no more a company, we are a group. With excellent support service, we have the right training, we have on-time customer service, we have technical support. Imagine bringing somebody that has not been in Nigeria to Nigeria, Whitey. He's a Whitey now. Mr. Mosin to Nigeria. We have technical support from them. We have capacity for any size of project. And I say this I've been in this industry, pharma, for a while. And I know when I say there's capacity in Kachi. Just think of it. And I can tell you, sitting on the table, that project will be done without issues. And we also can do the small ones. So don't say, these ones are big. We can do big, we can do small. Now, anybody without a vision ends up dying small. We don't want to die small. We have a future. Our future is here. See where we want to be. Can you see Kachi? Kachi. This, we did the groundbreaking some years back, 2 years back. And we are very hopeful in a short while. You will not see us in Ikeja. Who knows our office? Adeni Jones, Oregun, for those that know in recent times. Adeni Jones, usually, would have, if you know me before, who knows that song? You go know me again. We would have moved to this place. We would have moved. This is where we are going to. This is a Kachi future. This is a building that will be done in a short while, and then we'll move place. We'll have a training center, we'll have the labs, we'll have the offices, we'll have a manufacturing unit for products that can be done in Nigeria. We'll have all that in this and next level space. So, ladies and gentlemen, I hope you know a little bit more about Kachi. Thank you very much. No, I will sit down. I will sit down now. All right, let me have Mosin come up. I hope, yes. Mosin, please come up and do the introduce Stanley Fisher. Thank you very much. Thank you very much, Mosin. Yes.
To make this happen. My name is Mohsen Mesaudi, and I am the Senior Channel Manager at the Life Science Group at Thermo Fisher Scientific. I'm based in Morocco, in Rabat, and I cover North, West, and Central Africa. So I know Africa, and I know the African market very well. I have been doing this job for the last 5 years at Thermo Fisher, but I was in the life science business way before. Let me share with you just a little bit about what I feel today, here in this room. I feel excited and very honored to share a room with one of the brightest minds, not only in Nigeria, but in the whole continent. So thank you so much to be here with us. And I have seen so many of you behind screens. Professor Chika for so many years, and I'm so happy to finally see you, Professor Emeka as well. So today we are here together with Kachi to speak about innovation, about how we can bring the next level to the African market. And Dr. Lisa said something very important earlier. We need to stop sending our samples abroad. And this is something that we are asking all the continent to do, the whole continent to do. We need to stop sending our DNA for free to pharmaceutical companies abroad to know what we need as Africans. We need to do our thing locally. We have the knowledge, we have the brightest minds in here. Why are we still sending samples abroad? Okay, so let me go back to Thermo Fisher Scientific. We are the world leader in serving science. Thermo Fisher Scientific, we are about 110,000 people around the globe. We are everywhere. And most importantly, we are present in Africa. We have people on the ground in Nigeria. So please, look after them. They are here to serve you. They are here to present to you whatever solution you need. We have above 5,000 people doing just R&D all around the globe. We invest more than $1 billion in research and development. And we do more than 40 billion in revenue. So we take pride in our mission, which is help and enable our customers make the world healthier, cleaner, and safer. How can we help you and enable our customers make the world healthier? We have technologies. Precision medicine is the trend now. We can help you. We can provide those solutions to you. Oncology business, for example. We are one of the leaders on the market on precision medicine and targeted sequencing. And that's everything that you need for oncology testing. How can we make the world safer? One of our biggest businesses is the human identification business. We work with police forces, with even private labs, as we do with Kachi Lab. You can get paternity testing very easy, very safe, and you can help law enforcement to do crime scene investigation using our technologies. So we have a broad range of portfolios. We can help you set a lab from scratch, going from the small pieces of plastics to next generation sequencing, to high technology, high mass spec technologies as well. We can do whatever you need. You just need to reach out. Reach out and ask. We set up a call. We set up some time. We present to you. We help you get a solution to you. So that's Thermo Fisher Scientific in a nutshell. We have so many things to help you with. You just need to ask. And we are here today with the team in the region. Thank you so much for being here with us. And we will start by our biosciences colleague, Huwele, Dr. Huwele. Thank you, and please join us.
A Hello, good morning. I don't really like the doctor. It is too formal for me. So most of the time when I am in a meeting, I just say I am Owele Touré. So I'm based in Côte d'Ivoire, so sorry for the accent. I'm from a French-speaking country. So I oversee the Bioscience Division for West and Central Africa. So this is a large portfolio, a large division. We cover many things, and you will discover everything with me. As Moussit said, we invest a lot in research because we want to be up to date with you, with your research, so we can propose you the most accurate product, instrument, reagent. So our mission is to, we want to enable you to make the world healthier, cleaner and safer. So we help you for our customer focus. We help you to accelerate your innovation, enhance your productivity, and also have a fingerprint in your quality in the work. Most of the times, people are a bit confused when they see the different brands, but they are all part of Thermo Fisher. According to what you are using, is it an instrument, is it a plastic, is it a consumable, you will see different brands, but they are all part of Thermo Fisher Scientific. When you take Thermo Scientific, this is mostly the extraction kit, some plastics, and some instruments. You will see Applied Biosystems. These are also plastics and instruments. For in vitrogen, mostly reagents and extraction kits. So for Fisher Scientific, we have our colleague from Fisher. This is a distributor of Thermo Fisher, but they are fully part of Thermo Fisher. And for the others, there are some from pharma, drug discovery. So all of them, as I said, are part of a big company. And in Thermo Fisher Scientific, we have a different division. It may confuse you, but if you address a request to one of my colleagues, they can redirect to the right team, and you don't have to bother with that, who is in bioscience, genetic science. It doesn't matter. Just send your request and we will handle it internally. Please. So for Bioscience Division, we have 4 portfolios. The first one is sample preparation. After that, we have molecular biology, protein and cell analysis, and cell biology. So for sample preparation, it is everything we do for extraction. It can be manual, it can be also organic or automated. What we call organic is when you use your product, your reagent to do your extraction. You are not using kit. But when you shift to kit, we call it manual. And for the kit, we have different type of kits based on column and also bead-based extraction kits. And we come to the third one, the automated one, using our instrument. Please click on it. So yes, thank you. So we go to the low medium to the high medium. And it depends on the number of samples you are using and the volume range. If you have 6 or 12 samples, you just go with the GeoPrime. It will extract your sample for you. You just have to prepare your plate, add your sample, you put it in the instrument, and it does the run for you, the extraction for you. If you have more samples, you use the Kingfisher Flex, and you can go up to the Apex. They have the same number of reactions, but with the Apex, we have the option touch screen, and also the cooling temperature, and also the UV option on the Apex. So after, just for you to have an overview of the different type of extraction and the different sample you can use. So you can use cells, you can extract your cells, You can extract tissue from tissue, you can extract microbe, you can extract from plants, blood, so many types of samples, and you can do different, after the extraction, you can do different applications. So whether you are working in a plant lab, you are working in a medical lab or animal lab, you can use our instrument to do your extraction. It is not limited to a field of application. And when we finish with the extraction part, we come to the molecular biology part, but it only concerns conventional PCR. When you want to go on genetic part, my colleague are the one under you. But for the, like I said, conventional PCR, we have different types of thermal cyclers. If you want to use for routine, like for teaching students, we have an instrument you can use. It is affordable. But when you have more application you want to run, according to that, we can propose different thermal cyclers. And at Thermo Fisher, we are not selling only instruments. We have, as I said, plastics, we have reagents, and for the molecular part, as you can see, PCR enzymes, RT enzymes, restriction enzymes, and everything you need to do your work. We have plastics specific to our instrument, the Applied Biosystem plastics. If you have our instrument, please do not use competitors' plastic. It is not, no, it is not like we want to put the flowers on us, but if you do that, you can break down your instrument. No. Yes, if you have, this is that, I was confusing, but if you have our instrument, please do not use the other plastic. Just use our plastic, the Applied Biosystem plastics. But if you have competitors' instrument, you can use our plastics. I can give you plastics for free. You will let me know. So whether you have competitor plastics or instrument or our instrument, we have plastic you can use. Please let go. And after the PCR part, you have to see your samples. You have to use to image your gel. So we have what we call ePower Snap. So you can do that. You can use to see your gel. You can use that to see your gel. So instead of going and prepare your gel, come and put run the gel to prepare your gel, I mean, we have two instruments we call ePower Snap. So the first one, the number of samples of well you have to use is not enough. You can go up to 22 wells. But for people who have PCR as routine, you can use the ePower Snap Plus, because with this instrument, you can go up to 96 wells. So you have to buy the cassette. Everything is in, you just come, you put your sample, you put in the machine. With the camera, you can see your samples migrating on the gel, and you can take a picture. So if you want the instrument, you can have it. We can do a good deal with you on even on the cassette, so that with the run rates, we are all good. And also, Kachi is able to do some demo for you, placing an instrument at your place, so you can use it and see how it works. When we finish with both those two parts, we also have the flow cytometry. That is part of the protein and cells analysis. So for that part, please know that we have flow cytometer, we have a reagent to prepare your samples, to stain your cells and everything you need for the flow cytometry. And I would like to introduce you two of our flow cytometer Attune NXT. The difference between those two, the second one is able to capture images. But what is the particularity of our instrument is the acoustic technology. So we avoid clogging of your samples with the syringe technology. So the syringe push your samples into the tube and there is no clogging. Your samples go straight. You don't have a disorder in your samples, your result I mean. So this is a technology that is specific to Thermo Fisher. So having our flow cytometer, you are sure that your result will be good. Like how we can ease your work. So I took a study case for cancer, but please be aware that the instruments are not only for cancer, but it is just for you to have an idea of how you can use the different instruments for a specific subject, a specific study. So for flow cytometer, you can do a cell cycle analysis. You can assess the distribution of your cells across different phases. You just have to stain your cells with DNA binding, and you will understand the proliferation rate of cancer. Is it going fast? Is it going slowly? You can just identify, assess. You can also do apoptosis detection by using the same instrument. So it will help you to identify leaf cells, dead cells. So also for immunophenotyping, you can identify and quantify specific cell population. So we are not limited. And as I said, for you to have an idea, if I am in this field, I can use this instrument. So we have the microplate reader. With also the microplate reader you can use when you are doing cancer research. Not only cancer research, but for this is an example, detecting and quantifying proteins, nucleic acid, metabolites from cancer cells. You can also measure your enzyme activity. You can also assess your cell viability. And with our microscope, the imaging microscope, you can study the cell morphology, identify also if your cell is alive or not, and also visualize the proteins or cells structures.
Over a decade of HIV and AIDS research experience, Professor Aldo now also focuses on emerging viral diseases. She led 2 national reference labs at NIMA to achieve ISO 15189 accreditation, Nigeria's first public health lab to do so, and helped secure WHO pre-qualification from the Center for Animal Biology and Genomics, the first in West Africa. She serves on the WHO Africa Medical Devices Forum and the EDCTP-funded Talent Program, Advisory Board as a former Fogetri and HEMA Fellow at the IENPHI Leadership Academy. Please let's meet welcome Professor Rosemary Aldo.
Now please join me to welcome Professor Sunday Omilabu, Professor of Medical Biology, College of Medicine.
Professor Sunday Aremu Omilabu. Professor Omilabu is a professor of medical virology at the University of Lagos, hospital virologist at LUTH, and consultant virologist to Nigeria's Federal Ministry of Health. He holds a BSc from the University of Ife and Masters and PhD in virology from the University of Ibadan. He is a recipient of the Alexander von Humboldt Fellowship and has conducted research in Germany under that programs. He directs the Central Research Lab
and industry. Okay. My panelists will examine the benefits of highlighting how life science research and teaching can inform practice and industrialization, and how real-world challenges can shape scholarly requirements. So, with my audience here, audience of experts,
almost afternoon. Everybody, I don't know whether they have to get up and do the Buddha or something. I don't understand. This is Dr. Issa's thing you've come to. You're all quiet like this. I don't understand. Maybe you haven't given them, is it coffee with some gin? Nobody's recording this, I suppose, right? There's no gin. Okay, there's no gin, but there should be coffee. Morning, I don't know about you. I'm so excited to be here. I really am very excited to be here. We've been talking about this. We've been talking about this for quite a while, actually, and I actually got introduced to Dr. Issa because of this, through a friend of mine who knows how passionate she is in bridging gaps, in ensuring that we try and improve healthcare in Nigeria, here in Nigeria, by Nigerians, even at this molecular level that people believe that we can't do ourselves, but here we are because we can, and actually we must, to be honest. So I'm very excited to be here, and I now, you know, when people say some people are doers, Dr. Kate Issa is a doer, and that's why, even though we haven't been talking about this for very long, we're all already sitting here with Thermo Fisher, but other partners, and with very eminent, really very eminent researchers in the room. I mean, when I read the panelists of the program today, I'm so excited. And I really want to thank Kachi Group for the thought that has gone into this and the people that you have brought to the table, because I know that with all of us here, we can do this, and we must do this. And it's very important, I think, that because, you know, we say it and it's almost like we're paying lip service to it, but now being at Marcel Ruth, and the hospital will be 5 years in December, I'm going to the question that you're asking me. Thank you. And that in itself is only by God's grace. If anybody ever talks about what they do and doesn't remember that part of the story, then I don't know. I'm here, and Marcel Ruth is here simply by God's grace. That's all. Because if you know Nigeria, and if you know trying to set up anything in Nigeria, which I think you've alluded to, and actually in sustaining things in Nigeria, whether it be NIMA or the virology department in the College of Medicine, it's not an easy feat at all. Most of you are in this room because you know that it's not an easy feat, and because we all are doing our best to make sure that despite all the stories that things cannot happen in Nigeria, actually things can happen here. And when my husband and I were going through this journey of setting up Marcel Ruth, I always say that, you know, if we spoke to 100 people about this, 99.9 of them said, no, it's not going to happen. No, they will frustrate you. Oh my gosh, it's not even possible, you know, and so on. Actually, it is possible. You know, by God's grace. So it will be 5 years in December. We have seen just about 5,000 patients at Marcel Ruth. If that doesn't blow you away, it blows me away. Because even when I was coming to do this, if anybody had told me, in fact, the other day I saw a LinkedIn post that I did maybe about 18 months after we started, and I said, I'm so excited, I'm back in Nigeria after 30 years, and we've seen 500 patients at Marcel Ruth. You know, if you read the post, it was like, oh my gosh, we've seen 500 patients. We've now seen 5,000 patients. But what also, I think for me, is now becoming really key is the geography from which the patients come and how patients come. So like in the last 18 months, because we, like you, are collecting data, and this brings to the information about how do we pull research and business together in medicine. You know, there's the science of medicine, there's the clinical practice of medicine, but there's the business of medicine, and what Kachi Group have done here today is bring them all together. And most of us always forget. You know, those of us in clinical medicine forget to speak to our researchers who get very cross because without them, we couldn't be doing what we're doing. And then those of us who are now trying to run business in Nigeria, it's only at that point that we realize that actually there is a business side. Is that, you know, patients are coming from all over the country, and I mean all over the country, and they will just turn up. You know, we don't have a system of, people don't even make appointments. They'll just turn up with their, you know, bags with their X-ray, you know, films in it, and they've come from Adamawa. So I had to go and check the geography of Nigeria. So those of you who don't know where Adamawa is, just for me today, go and check. And when you listen to their journey, there's a lady who came from Lokoja, she was sitting with her husband at 7, 8 o'clock in the morning, and I was like, oh, but how did you get here? 9-hour drive from somewhere to Abuja, then from Abuja to whatever. That is the extent to which patients are going to get to us, to get the care for cancer in Nigeria. But previously, they would have had to get on a plane to go to India, or to South Africa, or to the UK, or to the US. Yes, they're making this journey, but guess what? They're coming with their family and their friends. They're able to go back to their homes, whereas most of them ended up in all these foreign countries, sometimes for up to 9 months or so, because treatment of cancer can take quite a long time. So we're now having this opportunity now to treat our patients in Nigeria on a clinical side. And apart from the 5,000, within the 5,000 patients we've seen, we've looked after almost 200 children.
Thank you.
With cancers.
Thank you. Thank you.
Yes, no, so I was just going to say, but now we're looking at it from a more, and this is where the world is going, precision medicine, the individual care of patients, looking at their molecular and genomic studies, and making sure that we are giving the right treatments to the right patients. I know there's colleagues here from Covenant University. Professor Solomon Rotimi chairs our ethics committee at Marcel Ruth, and I know the work that's been done. And I remember going to a presentation where he showed, for example, in simple terms, but I mean, there are obviously very eminent scientists in the room, that in prostate cancer, for example, in men, if you look at the genomic studies that are coming through now, you put the one for black men and the one for white men, and it's almost opposite. Just on that basis. You don't have to remember anything else. It is basically the opposite. What we find in black men is the opposite from what we find in white men. The drugs we're using in all our patients were developed for white people. So, Kachi Group, thank you.
Thank you. Listening to all that she has to say, the history, we cannot agree that there is a huge relationship between the researchers, the academia, and the industrialists, the solution providers. Okay, bridging the gap between research and business requires a courageous shift of mindset between these researchers and the industrialists. Okay, this requires fostering collaboration and between academic institutions and industry players, alongside addressing challenges like intellectual property. You know, our researchers, they're so gross at protecting this. You know, they don't want to release it. They want to hold on to it so that so someone else doesn't steal it. But I think the major reason for this research is to provide solutions to the real-world challenges, and that's life-threatening challenges, and provide solutions to it. And that is why I would move on to Professor Audu, and I would ask, how can, coming from the research environment, okay, how can we foster an entrepreneurial culture within the life science community? All right, thank you very much.
Before I continue, I want to recognize my mentor. For me, he was my supervisor for my master's and my PhD. So when I got the flyer, I was like, oh my God, Happiness didn't tell me that. She invited my professor. I would have just stepped down. So it's a privilege to be here with you. Thank you very much. And I want to also say thank you to Kachi. When Happiness was speaking, I just could relate with her because we have benefited from Kachi. Even when at the point what the supply was just not what we wanted, but they went the extra mile to get what we wanted. And I want to say thank you so much. So, how to foster relationship between the life science and research?
How to foster entrepreneurial culture in the life science community.
Okay, thank you very much. So for me, I think that the life science, like Kachi and some others who are into all of these products that we use in the research labs and the university labs too, there's a lot that we need all the time. And we just believe that we should work hand in hand. We just need to, we should be partners in progress. We need you and you need us, okay? And we don't just want products just dumped on us. We want that you have the solutions you say. So when we have challenges, you are there with us to help us resolve it, okay? So we feel that we need to work together. I probably just give examples of what we are going through now and how we think Kachi can work with us. We have some equipment that we have gotten and they are broken down. To fix these things, what we are hearing is just too much. We are government, we are not a private institution. You would say government has all the money. Well, it depends on what trickles down to you at the end of the day. You understand? You have a big chunk there, but what trickles down is quite small. Okay, so we really don't have so much as because it's government. No, not really. So we have these equipment that are not working. And when Owele presented and said we should not use any other plastic media, and I said that is what we don't want. That's what I was just whispering to my professor. I said no, that's what we don't want because we have some of these equipment. We must use their own. It's a closed market. Closed system. We would want you to open up your lips. But I got something from what she said. She said if we want free, that she can help us. I just took note of that. We are done. I will meet her for the So we want our equipment to function, not just to be there like museums. We want them to function. As we are, we're just considering whether to go get one equipment or the other. And we're like, I was discussing with Dr. Shaibu. It's like, these people, this one is close, these people, I don't know. I'm still considering, I like the quality. Yes, I like the quality, okay? I would want quality in any life science organization so that when you get this reagent, you are sure that is the reagent. If this is the concentration you want to get, it is. Because I've heard of stories where in some places they get a chemical thinking that it is absolute. They then dilute it in a pathology lab to do autopsy. And they discover that the autopsy, each time it fails, the body decays. And they were like wondering, the pathologists were like wondering, what's the problem? This is the simplest of all procedures. Until they dug deeper and discovered that the quality of the reagent we're getting was already diluted at the time we were doing it. So for me, quality number one on the line, all right? And then quality costs money. I understand, but we want to be able to access it. If we have to, if there is a way we can stagger the payment to ensure, somehow, we want it, but it should be affordable. Okay, so we know you're there in business for profit. We are doing research to make new discoveries, advance in knowledge. Okay, it's not for profit. And for business people, they want quick returns. Ours could take long, before you make a discovery, before you. So it's like, we are not at the same trajectory, but we need to find a way to come together and help one another. So for me, I think we are partners in progress. Whichever way, we need to work together and find a way that's, a common ground to flow. We like the quality.
Her team are listening. They understand the voice of your cry for quality, and they will serve you surely with it. Okay. There's something with Eva's perspective. It is possible to accelerate development of life-saving therapy. In his speech, he was saying that we don't need to transfer DNA for free. And Dr. Mrs. Kate is an advocate of, that is where we can actually drive this innovation. That is what the seminar is all about, empowering innovation in life sciences and research. And for me, I'm sure our Professor Omilabu will be able to help us to highlight on the exciting opportunities for collaboration between life science research and businesses. How can we collaborate? How can you help in feeding to the industries to serve you? Thank you.
Thank you very much to my co-panelists and to my colleagues on the other side. It's a pleasure to be here. And of course, the purpose I appreciate Dr. Kate Issa for this kind of invitation and for actually putting up this seminar as well as this topic. The topic is very, very germane, and we've been talking about this for long. I hope Dr. Chika will still remember in one of our conferences some years back that a lot of things are going on in both the universities and in the research institutes which are not known to the public. And that's where the big problem is. There is a gap, truly, between the research institutes, the universities, and the business world. And of course, the phrase, "gone to town," is not actually working per se, because that's the essence, so that we bring the gun to the town to showcase what we are really doing in our cocoons, in those laboratories. We said that there is now a time for us to look into how we actually organize this type of meetings, so that we invite the industrialists, then we scientists too also will come to the table, show them what we are doing, let them know what our challenges. Truly there are challenges in this side of the globe. As even scientists. Life science is not just what you do by way of mouth. You need equipments. Yeah. And the equipments are not there. Now they showcase all those fabulous machines here. It's not just for mouth. If you ask them how much it costs, I'm sure my university cannot afford to release even a quarter of the money for my own lab, talk less of other laboratories. So the challenges are there, but that notwithstanding, we are trying as scientists in the laboratory, in the universities, to train younger ones. But there is a limit to what you can impart when the facilities are not actually there or they are not working. And that's the big challenge. I will say that they don't know what we are doing outside. Yes. We are only doing what we are doing to get our promotions, to become professors. Most of the PhDs turn out. How many of them have impacted on the society of ours here? Because we know they don't have the real facilities to do what essentially will benefit mankind. We are not after product. Over there, they are after product. Product design is the key thing, even at the secondary school level. But at our own university level, we talk more of theory. We are theory experts. But when it comes to hands-on, to actually actualize, you will see some senior students, they'll be amazed when they see DNA after pelleting it. They will be amazed to see white blood cells after separation. I told them, yes, that was I was amazed too when I separated the blood on the BBMC at my master's level, where I got the facilities to do it. And of course, the lot of things are to be happening in our universities and research institutes. But for the lack of reagents, lack of machines, Professor Adu mentioned it that the problem of maintenance, equipment maintenance is very key. It's only when you are able to recalibrate your equipment, not to even come to repairs, recalibrate. We need to recalibrate at specific periods of time, not until the machine breaks down. But we don't have experts around to come and do it because they have to be certified. But thank goodness, things are changing now with the NCDC. So we've been able to judge on, they've trained some bioengineers. I'm sure Katie has a lot of bioengineers here. They've assisted me in my lab, so I must appreciate that. Several. Even though we don't have money to pay. But we got our machines recalibrated separately, which actually made the work go smoothly. And of course, when we sent out samples abroad to just validate our results, we've been on top of it. And that made them to believe in Nigeria that a lot of things can happen in Nigeria if we have the right environment. There are a lot of things to do together. University, research institute, and the industry. They have a lot. Now, Trump has changed the whole scenario now. Funds is no more coming. So we have to look inwardly to see how we come to our assistance, both the industry, the university, and the research. We need the fund. The industries have the money. We researchers, we have the idea. And then we have some equipment. So this is the right time now for us to come together to a special line, looking into what we can offer. And of course, training our students will be easier when we know what the industries actually want. We can easily put students on them, or go to that company, go and do some 3 months on-hand training there. And that will inform what we do in the lab to actually make sure we produce what the industry would like to commercialize. So there are a lot of things to actually benefit from both the university and the industry working together. Because we say we have to be to the town. We are gowns, so we have to take our gowns to the town so that we showcase our case. Thank you very much.
Thank you, sir.
So I think, well, that's exactly what I was going to say actually. So I think that also, unless a lot of the clinical staff, people don't have the experience in research. That's part of the problem. So one of the reasons why I understand this, or why I had this conversation, is that I had the opportunity to do full-time research for 2 years during my career. And actually it was only because the person I was working for, the professor I was working for, when I finished passing my exam, said to me, you know, for you to stay here and get a really good job in a teaching hospital, you don't have any research experience. So long story short, and it's very difficult to get into research as a clinician, And if you don't, now the medical schools in the UK and the US are even putting it in the middle of their medical school degrees. They're doing something called an intercalated BSc, because it's now seen to be really important, this whole thing of understanding how important research is. So there's been a really big gap between the researchers who are in the lab, who understand that without them, we can't make this progress. But on the other side, you're churning out doctors who don't understand that they're in the talk less of gown to industry, even gown to medical people. Medical people don't understand the amount of work that's going on in the research lab. So it was only because I did that I really understand. That's the first thing. I also want to say something about, which you just brought up, that there is still, we cannot sort of say, okay, the government hasn't got money, and it's okay, because even in the private sector, it's extremely expensive to run anything. I mean, yes, you're saying that maybe we can get access to funds, but actually it's difficult, and that's why there are not 10 cancer centers in the country or other specialist hospitals. It's extremely difficult to set up. Nigeria is extremely difficult because we have this system whereby for everything, I mean, Thermo Fisher must have a third party to supply your equipment in Nigeria. Now that third party, if their machines are, and Thermo Fisher didn't pay me, but I'm just telling the truth, we haven't bought equipment in Nigeria. No, I'm going to explain something. So even if Thermo Fisher says the thing is 25,000 naira, if the third party decides to sell it for 125,000 naira, there's nothing they can do, which shocked me. There is no limit. The third party person can make it whatever they like, and they're the only people that can supply you. So you can only buy from them. And guess what? They're the only people that can maintain it for you. So talk less of plastics or whatever. So we have a serious problem. We brought a radiotherapy machine into the country. The cost of it, if you compare it to abroad, is, so they can't even believe, I mean, it's expensive, but it's so much more expensive here. But this is, and the reason I'm saying that, we need people like Dr. Issa and other people in the room. We have to go to the government. We can't just say, oh, the private sector can take it over, because actually it's very expensive and we will not be able to provide this care for lots of people. We have to support you, Naima and so on, by saying that you have this talent here, all they need is the equipment. Find a way of providing this equipment directly to them. And I'm sure that even places like Thermo Fisher and Co are happy to partner. Their hands are just tied because we have this system in the country. I don't even know how it came about. And for every single thing you buy, there's this third-party person. So every supply chain, there's a third-party person. So everything is so much more expensive. And talk less of electricity, for example. Let's not go there. Our electricity bill went up from 3 million per month one day to, I think, 17 million overnight. Yes, this is Nigeria. So people look at you and say, oh, you're in the private sector, as though it means it's easy. It's not easy. And we also have to be careful. How much of it can we pass on to patients? How much? Think about it. You can't. So we're here, but actually we're all doing CSR. Yes, we're doing corporate service, because if we were set up somewhere else, we will be charging so much more and making so much. And that, I think, is something I want people to understand. So all of us have to work together. We do. We have to work together. In fact, before I went abroad, I went to Naima because that's why I wanted to come and do my postgraduate. But everybody was leaving at the time to go to Saudi. Remember, when and that's how old I am. All the professors were going to Saudi. Yeah, I'm going to be 61 in June. So, yes, that's what happened. And that's why I ended up going to the UK. I wanted to work at NIMA, but all the professors were leaving at the time. And this is the problem. But I think we have to work together, which is what we're trying to do here, to start now. But let us not forget, we also are the people who are going to educate the government to say, we need this equipment in these places. We need regular supply. And without the regular supply, we cannot make these changes in healthcare. And we cannot actually make the care is cheaper or more affordable for patients. Because abroad, there's all these collaborations. You will find Thermo Fisher having a lab in the university, for example. But because they make it easy for them, you will find Kachi labs based in universities, where they decided that they're going to help, but the government too will bring their own, and that's how
we can do this. Thank you very much. Thank you, Dr. Before I get back to the audience, I would like Dr. and Mrs. Kate Isa to highlight on some of the things, factors you would like to see the researchers and the business professionals do differently.
Thank you. I will start by disagreeing with my co-panelists. The only one I will agree with is Professor Mungila. Professor Abdu, you said something about instruments not maintained, breaking down, and and the cost of the repair. I think maybe the problem is the exchange rate, because I think the cost stayed the same, but when you convert it, it's mind-blowing, it's crazy. That can be a big problem. But it's important, it's good that table, this table is here, so that hearing it, live. We want to be able to support these great institutions and make sure they succeed. Their success is our success. So we will look into your pain point and find solutions with the help of the manufacturers. My darling sister talked about middlemen. And when she was talking middlemen, we're right in the middle, right? They say when they talk about old bones, old women get uncomfortable. But we're not in the league of these radiology machines. I wish we were, that we were the only ones. They have many wives here. We're not the only one. And so we can't even afford to jack up prices, otherwise we won't win. But we bring value, which is very important. We bring value to our customers. Yes. What can the government do? What can we do? How can we win? Everything we're saying here, all that we're doing is like Band-Aid on a festering wound if we don't address the fundamentals. We're graduating students, primary, secondary, university, based on analog curriculum in a digital world. And we want to bring them out and tell them to do research, discover drugs for cancer. I was at an, EOTIC conference many years ago, and Professor Rotimi spoke. And he did a presentation. He showed the one thing at that conference, I think it was done next door. And that, I haven't seen him since. I don't know him personally, but that one slide changed my life and made me a crusader for Black people looking for solutions for Black things. It's not just the cancer, it's not just the disease, it's also building materials. We import things from Italy to build our house, and the things fail because it wasn't meant for environment. Our weather will not take it. Your importing is expensive, it's failing, it's damaging. We need researchers in every area of life. We need Africans, like Monsen said, to find solutions for the needs of Africans. We can't do it with analog curriculum. From the year 2000, I started pursuing every Minister of Education. You must update curriculum. You must upgrade science curriculum in the country. When the minister catches the vision and they're about to do it, they remove them. You start again with a new minister. Only 2 ministers or 3 maybe that I didn't see. And I'm still pursuing them. I haven't stopped. To update, upgrade our curriculum so that we can use digital curriculum in a digital economy so that the kids come to you with tools, with basic knowledge, and you can easily train them to become researchers, innovators, and things like that. I remember, I'll tell you in real life the story. We, because of this, we adopted STEM, equipping science with STEM, for science pedagogy. And we reached out, we got a company who wanted to donate, some whatever products or service to a school, a Jebu Muslim school. We told them, don't give them money, give them science. and they got Kachi to build, like from dirt, equip a science, 5-streamed science complex equipped with STEM pedagogy. And the Ogun State governor, when he came to commission it, because it's an Ogun State school in Ogun State, he was so blown away. He told his advisor, make sure you get with them. We're still talking about it's been 7 years. Anyway, so we approached Lagos State, and the governor actually has a commissioner on STEM, and a special advice on STEM. And that was lovely. Ronke, Madam Ronke, let's help you. She goes, US government is helping us, they're supporting us. I said, well, what exactly are they doing for you? Because I had spoken to the person in the US government in the consulate. He had come to my house for dinner, and I was trying to get funding for modernizing curriculum in Nigeria, and they said that's not what they do. They're not interested in that. I said, what are they doing for you? They're giving them robotics. Oh, really? I said, please collect the robots. Give them to your children as extracurricular playthings. Let them enjoy it after school. But we're talking about core curriculum based on STEM, that your children will be trained to design and develop the robots and program them. And these are the knowledge, idea you need to do the research, today's research, to discover the solutions we're talking about. And that got her interested. We took her to see the lab. They went for a pilot. We're concluding on the pilot. I think the Lagos State will roll out STEM, digital curriculum for their secondary schools. We need the federal government to step up to it, because the federal government controls everything. So you're going to take me to a lab, sir. You bring him to a lab, and we're going to make him upgrade the science curriculum in Nigeria. We've been fighting, we keep contending. You're a crusader as well. I know you fight, you're a fighter bomber for the Nigeria, for the cause of Nigeria. Yes, so we need to modernize the science curriculum to bring it up to grabs. And I want to go back to Professor Rotimi. He showed a slide that showed the new advances in prostate cancer, the markers and, all kinds of solutions that have been developed. And he showed, one of the slides showed demographics of the people in the sample pool for whom these solutions were developed. And there was about 5% black. And I asked him, I said, what does this mean? Why only 5%? He said, well, in that study pool, that was the representation in it. I said, so how does it affect the black people when they use this product? He didn't answer me, but I can use my tongue to count my teeth. It means that you're not sure it will work for you. It wasn't developed for you. And I think that number will go down. Maybe they did it in the US and they were trying to make sure the black Americans didn't fight too much. But the African genetic makeup is even very much different. So we're taking medicines that were not designed for us. And medicine is getting more personalized, more. If we do nothing, we just sit as sitting down, export our DNA, which is not, doesn't make sense to do, with all the intelligence, with all the knowledge, some of us have gone to the best schools in the world. We've kicked ass, excuse my French. We went dumb. Why do we live like we are dumb? Government, we will try to influence them, we will try to talk to them, but let's not stop there. Let us do what we can where we are to change things, to turn around things. Let us do what we're doing today, building bridges, holding hands, collaborating, trying to find solutions. Somehow, I think, when we're doing it and it's working, the government will come around. Yes. And I don't consider you government, by the way. Because I don't consider you guys, because you're doing serious work. You're not sitting somewhere signing documents and collecting money. You are actually doing work. And if anything, the system is not giving you the support you need. Yeah. So we are all on the same side of the room, but let's make it work for us. Thank you.
Thank you. Getting back to the audience, you will agree with me today that we've had a fantastic discussion. The house is really full with experts in the field of research, the industries. And I know that in one way or the other, we might have 1 or 2 questions for them. Happiness is not joking with her time. She's been sending people to signal me from there. So I have a very short time. I've expended my time actually, but I would maybe appeal to take 1 or 2 questions, very critical questions that we will all have to go home with. Somebody, okay, 1, 2. Maybe, can we just go with 2? 2. Yes, 2. Okay. Please, someone should help us take the questions down so that we can.
And I want to appreciate Kachi for inviting us to be here to be part of this. And I want to appreciate the professors and the panelists. I want to make a few statements, not majorly questions. One, from what the vision of Kachi is, I would like to encourage them to make provisions for grant opportunities for researchers. Because that is one of the ways where life science providers and researchers meet. If you have a vision for something, you can create an environment for it whereby you give grants to opportunities for people that can generate the data, genomic data, DNA, nucleic acid for you to do what you are doing, you are looking for. Because most of the times, that is what people from outside the country do. When they give you fund, they will have to go with what they give you fund for. And then the second thing I want to say, I'm from NIMA. My name is Dr. Shaibu. I'm from NIMA. Sorry, this is, I have to say this, because Prof mentioned my name there. Currently, we have about 7 Thermo Fisher equipment that are not in use currently in my lab. The reason is because we can't afford the cost of the periodic maintenance. Because when you buy an equipment, there's quality. But you have told us that we have to be doing periodic maintenance, and every 1 year, you are giving, for instance, we have QS5 that we've not been able to use for how many days, because we have a quotation for periodic maintenance of $5,000. We have a QS7, $6,000. We have a QS3, $5,000. We have a mini amp, $2,000. We have another simply mini amp, $2,000. Everything together about $20,000. So as a researcher, I would think this way. That one, I don't have money to keep maintaining this thing, neither buying what is needed to run on this thing. Why won't I rather go and buy a cheaper machine and use your machine to validate it? And then be using the little money I have to run it. Because that, as a researcher, I would think that way. Because I cannot afford what you are giving me, but I know at the same time that thinking from my brain, there are other machines that are cheaper I can afford. Even if it runs out after 3 years, I know before it runs out, I will be able to afford to buy another one. But the money that we use to do this maintenance will be able to buy that for me. So why would I put in 20,000 naira to do a maintenance that I know that in another 1 year, to $20,000, in another 1 year you're going to give me that? How I won't be able to afford that as researchers. And it's one of the biggest issues that we have with Thermo Fisher equipment in Nigeria. We have many labs that have Thermo Fisher equipment, but they are moribund. They are not being used. They are just there, parked somewhere. So Thermo Fisher should just look at this, and I tell you that you will have a big market in Nigeria. Thank you.
I think when you design equipment, probably you should do some kind of testing that design in such a way that it will be suitable for this climate. And now I'm just speaking of with Engineer Rashid now. We have been having issues with AES because they complain of moisture absorbing the gas box being replaced severally. Is a major problem because the environment is not suitable for this kind of equipment, and at the end we keep changing, we are spending millions. And also the ELISA plate reader just, in fact, personally I would not want thermal products because of the issue of reoccurring breaking down. Aside that, one thing I also want to make them to know is that I know that they do CSR, they give donations. Yes, I did my postdoc in Germany, UKE in Hamburg, and at a point they give some supplies to our labs as a donation, but I've never seen, probably through Kachi, they will send us some of these things. I think they should be encouraged to do such. If you do that in Germany, please reproduce that in Nigeria as well. So basically, my point is to Samuel. Thank you very much.
I also want to appreciate Kachi and Samuel Fisher for this platform. And I want to congratulate the panelists. They've had a very vibrant section. The only challenge is that I sympathize with my friend over there, who is the only man. And that means this panel is heavily gender. Next time, make sure you balance. So I want to ask a question, and I also want to make some comments. A lot have been said about treatments not working for blacks and all that. But I believe one of the reasons why treatments are not working for blacks has to do with clinical trials. That's my belief. A lot of blacks are being excluded in clinical trials, and blacks are not subscribing even to clinical trials. So I want to ask Dr. Dusi, why do you think blacks are being excluded from clinical trials, or why do you think blacks are not subscribing to clinical trials? So that's the first question. Then the other ones are comments. Let me start with the curriculum by Dr. Issa, who talked about a lot of problems with our curriculum. I agree with her. Most of the things we teach are out of scope and doesn't tally with what the industry needs. But I'm glad to say that the NUC has started doing something. Recently, we have what we call the CC Max. CC Max, where universities are allowed to customize, some of their curriculum based on their needs. And I'm sure that's going to go a long way in solving the issue of the curriculum. And then I also want to talk about the collaboration between researchers, industry, and the academia. Let me start with that between researchers and the medical people. Okay, previously there used to be a lot of challenges, dichotomy, between the medical people and the researchers. But it has become better now. Better in the sense because the researchers know that the medical doctors need them, and the medical doctors know that the researchers need them. For us as researchers, we don't have access to patients. A lot, my colleague have been mentioned here, Professor Rotimi, sorry, I work with him. We don't have access to patients. So we can't get patient samples to do our work. But the doctors have access to patients. So we have to work with the doctors to have access to patient samples to do our research. The doctors don't understand the diseases as much as the researchers. So they have to rely on our research to understand the diseases better and know how to treat them. And that is why both the researchers and the medical doctors need themselves. And that collaboration is very, very critical. And then the other last one has to do with industry, academia, partnership. My brother over there talked about the challenges. We've had that narrative over and over again, challenges with the industry and academia. But I want to tell us here that the challenge is that, there is a disconnect between the industry and the academia. But there is work for the academia to do, and there is work for the industry to do to make sure that that collaboration is effective. When I was a director of research in my institution, I made it a policy, or rather I made it a priority to make sure I bridge the divide between academia and industry. And what did we do? We organized a luncheon. We organized an elaborate luncheon. Invited the industry captains, to come to our university. And we set up an exhibition. Okay? You know, people came with their products, exhibited, industry came, looked at the products, dined and wined with us, and then discussed with the researchers that they were interested in their products. So we cannot continue to say there is academic industry divide when we have not done something. That is one aspect. Then another thing we did is that we started what we call town and gown seminar in our university. Town and gown. Okay? What does that mean? We invite people from the industry, people that have the practical knowledge, to come and give seminars in our university so that researchers can learn, know where the gaps are, and begin to design research that will be impactful. Then the third thing we did is to appoint people from the industry as co-supervisors, especially on our postgraduate programs, the postgraduate programs. We appoint people from industry as co-supervisors or observers when the students are doing seminars and proposals, so that we can harvest their comments. And the students can go back and redesign the research so that they can come up with products that can impact the society. So that is what the university can do. And then, lastly, I know that some universities will say they don't have money, but you require the will. You also just have to have the will to do that. Our university is quite young, but you can agree with me, we have made some impact in the higher education sector as well as the research sector. Recently, I can tell you for free that our Chancellor, instituted a research grant solely for product development. Product development. We want people to come up with ideas that can lead to product development. I don't want to mention the amount because if I mention it, it's quite, huge. And then, what can the industry do? Industry, they also have what to do. And what should they do? The industry, they are making money. So part of the profits they have, they can funnel it back in the form of grants to sponsor specific research that will benefit them as the industry. If they feel there is a gap in the industry, they can bring funds and then give seed grants. People can begin to do research in that area. That's one thing they can do. The second one has to do with market intelligence. Most of us in the research space, we don't know anything about markets. We don't know anything about commercialization. So the industry can also build capacity of researchers in the area of market intelligence and in the area of commercialization. Thank you very much.
Thank you, Professor Iwala, for he's here in the house. He would visit your seats, the man from Naimaria. He would visit your seat shortly and guide you through how you can get to it.
Thank you. So, can you hear me? Yes. Okay. Just to reply on, does it mean that his money went to waste paying that insurance? We pay for comfort. We pay if we get sick, we got an insurance that can support. And it's the same thing for cars. We pay car insurance to when, if, God forbid, we get an accident, we have a budget that will cover fixing the car. We do not go and buy another car if the car breaks down. Otherwise, it's not sustainable, it's not affordable, and a lot of problems come afterward. If we are sick, we're not going to go replace us. We're not going to replace a heart, or a kidney, or it costs money. It's the same. That's why we have insurances for instruments. You buy the insurance for the systems, so you can cover your instrument. Because let me tell you, for example, for CE instruments, the cost of the contract has nothing to do with the spare part. And I can tell you from experience, one spare part costs more than the cost of the insurance of the instrument. So when you pay for an insurance, it covers spare parts and hands-on time by the engineers to fix the instrument. So it means that let's say you pay $10,000 for an insurance contract on an instrument, for a CE, for example, and you have the oven breaks down or the laser breaks down. The laser only, I think it costs about 30K. It's not 10K. But we take it in our responsibility to deliver to you that whatever spare part is missing or that breaks down. So it doesn't cost a lot when you put the calculation at the end of the day. So that's the whole idea of the insurance. Don't wait until the system breaks down, but cover it with an insurance. Go for 2, 3, 4 years so you can negotiate pricing. Don't go for 1 year. Don't wait for the instrument to break down, because otherwise you will need spare parts and otherwise you will need intervention by engineers, and that's what takes the bill to be high. And it's the same problem everywhere in the world. It's not an African problem. It's not a Nigerian problem. It's a global thing.
Can I just say, I think maybe you slightly misunderstood. I don't think anybody here is saying we don't understand the importance of maintenance contracts. I don't think that's where anybody's coming from. The question is, there's no money. And there's no money in dollars, right? And there's no money in dollars. And also sometimes when that maintenance contract was signed for, if I speak about what a CT scan and a linear accelerator, when we signed the maintenance contract, it was 300 naira to the dollar. We were clever, because my husband is in finance, is that he refused to have a maintenance contract that was dollar denominated. And to the lady who was trying to say about providing in the sector to suit the sector, moisture, whatever, you've got to look at the market. This is a market where you can wake up one day and the exchange rate has gone, it's totally out of your control. We understand that we have to pay the maintenance contract. I mean, I don't have the official equipment. I'm just trying to explain to you, maybe it's not about that. They understand totally, but they've got to survive. They can't find $20,000 to pay a maintenance contract, especially in an institution that is government owned, right? And even if there is the money in the government, in the system, we know, but to get that money at the time that the maintenance contract, I mean, because I think we came here to tell the truth, right?
Yes.
Let's not pretend. That's what it is. So you've got to think, you've got to pivot the thinking in this environment for what is happening today. Because there's no other way. I mean, that's why there are many pieces of equipment across the country that are not serving their value. And I think the question about also reagents, because we've had that problem in our laboratory, when we have ISN Roche equipment that has, you can only use a particular reagent. In the end, we have to go and find an alternative, and that's even in the private sector. Forget it. Because at the end of the day, if the cost is so high, you're not going to survive. And everybody here has to survive, and I think that's why Dr. Issa brought us here, is how do we have the conversations so that we survive? So it's either you make it Naira denominated, or you think that, well, for these institutions, they're not private institutions. Did you pay me? Because I'm working for you. Naima, I'm working for you here. But we have to be serious, and I also want to say something, please. You know, I mean, a lot of thought and effort has gone into putting this together. Let us live here really supporting one another. Because it is possible to support each other. You know, people who said that they were waiting for the US to help and everything, but they weren't getting the grants. right? I mean, I might not get it now, but for some years, people would get grants, and then let us be our own grant suppliers. Or let us find the solutions. Let's not pay lip service to this. You should mention about the plaster, because otherwise, there's no need to come here. All of us taking time to come from all over the country and leaving the jobs that we came to do. Let us live here so that NIMA can function. Professor's laboratory can begin to train these students. And here I am, I'm already thinking to myself, maybe Marcel Ruth should look at how we're going to support a few students or something like that. We have to do these things, yes, we have to. And we can't wait until we have the money to do something, then we do it. If we waited for the money to build Marcel Ruth, there will be no Marcel Ruth along the journey. That's the truth of the matter. Let us please, we come here today, let us listen to the truth of the matter, right? And then see how can we help each other make this better, because we have one common goal, which is to try and treat our patients in the country, and to try and I'll just quickly answer the question he asked me about clinical trials for Black people. So we have a number of issues. One of it is even a lot of our patients present late with advanced cancer. Most clinical research programs, trials, are for people who will benefit from the drug, because the drug company is trying to see, is it going to work? So if the majority of our patients are presenting in stage 4, where we can't do anything, they're not eligible for clinical trials. That's the first thing. We're doing a lot of work, a lot of advocacy and awareness, and it is changing. People are presenting earlier, but we still have a problem. There is the religious aspect. People will come, you will tell them what we need to do, chemotherapy, whatever, it's not my portion. Even if they understand and they listen to you, when they get home, somebody says, chemotherapy, no, never, yeah, church. We have people, they'll come back 6 months later, having been in church for 6 months, and then they're now advanced. They presented early, we could have done something about it, here we are. There's the cultural issues, problems, and then even to take normal drugs, normal chemo, normal radiation, talk less of when you're trying to talk to them about clinical trials. So we all have a job to do in the room. That education, that awareness, which you, Prof, has just really elucidated, how can we do this in practical terms? Researchers invite industry people to your lab. Ignore the fact that you think that they're not, whatever, that they have too much money, they don't understand our problem. They do. And industry people, we have to go to the research people. I've promised I'm coming to, this NIMA was where I should have actually gone before I went to England. So I'm going to, and we have to work together. Okay, thank you.
Thank you, Doctor. You can agree with me that she has gone around the questions and preferred solution. And one thing striking that she said is that we should go home helping each other. We don't have to wait for all the money to come, for the governments to come down, although they have to do their parts, but we have to hold our hand. We have to create a chain that binds all together, closing these gaps, bridging these gaps between life science, teaching, and research, and the industry. Thank you very much, my panel members. You've done a very good job. Thank you to the audience.
Okay, so while they are taking pictures, we'll have a quick break for about 15-20 minutes, just a tea break.
Okay.
So we set up an exhibition stand just by the door. We brought in some of our equipment, and he wants to notify the qubit, fluorometer, and the rest. So you can take advantage of that as well. While we are on our tea break down there, we are convening by 1:25 for the next session. Thank you.
For Sanger sequencing, it has been the bedrock of confirmations for a very long time, and it is the gold standard for sequencing and for understanding confirmation of genes, for understanding confirmation of different targets. Next slide. So, just to give you an idea what the qPCR and digital PCR ecosystem looks like as we narrow down our conversation, right? Our qPCR ecosystem is quite huge. We have from the Quantstudio 3, the Quantstudio 5, which you're all very familiar with, the Quantstudio 7, and now we have Quantstudio 12K, as well as the digital PCR, which we have put in the same family as our qPCR family. And as we go along, I'll try to show you what the differences between the qPCR instrument is from the digital PCR instrument, and why I think it is particularly very important for each of us here to lead the innovation with moving towards digital PCR, and what applications we believe that you can and should be using them for. Right? So within the qPCR ecosystem, we have instruments on one side, like the Quantstudio 3, the 5, the 7, and the 12K. We also have assays. So, and we have master mixes and all of the other nice reagents that come with that. So with the assays in particular, we have assays, primers and probes that help you to identify very specific targets. So we have 20 million plus assays that help you to identify anything from, you're trying to genotype, so you're trying to confirm different kinds of SNPs. And different kinds of SNPs are particularly very interesting because they can tell what kind of genetic disease is happening or what kind of genetic disease is not happening. So the National Center for Biotechnology Information has very nicely put together a SNP database and has assigned for every known human SNP an RSID. So if you have the RSID and you go to our website, you can only just search for one, and then you find an assay that helps you to confirm presence or absence of that SNP, which is really, really important. Finally, we also will provide you with service and support for all of the instruments within our ecosystem. I know Musin has tried to give a really nice example around insurance, but just to also buttress that point a bit around service and support, for every instrument you buy from Thermo Fisher, and it's very important to say, to recognize first, Thermo Fisher is a global company. We are in every single country in the world, right? What it means is that if Uchenna and Co, goes to Kachi and buys the Quantstudio 5 instrument and then resells the Quantstudio 5 instrument to Professor Iwala, for instance, and promises heaven and earth to Professor Iwala, and for some reason, 2 years later, Professor Iwala needs a calibration plate, and he goes back to Uchenna and Co. Because Uchenna and Co is not a recognized channel partner for Thermo Fisher, it is then unable to fulfill that promise. And then the first side fact is you have then created a scenario where the cost of the instrument coming to you is extremely high because Uchenna and Co has to put a margin on the margins from Kachi.
Bacteria as well as viruses, there's application of next generation sequencing in gene expression studies as well as inherited disease studies. But for today, I'll focus primarily on precision oncology and then reproductive health. So I'll start first with precision oncology, or precision medicine, as some would say. Typically, everybody, especially more recently, we're all interested in precision medicine or precision oncology or personalized medicine. And in fact, most of us here, we want to move from the generalized therapy to a more targeted therapy. So that's why, next slide, in most organizations, especially healthcare organizations, in Europe, even in North America, in North Africa, as well as South Africa, they usually have a department of precision medicine because we value or want to start giving patients the right kind of therapy because we believe that would be more suitable to them. And that's why in most cancer conferences or where people gather together and want to start talking about cancer, 3 major things that would really be at the top of what they we'll talk about. Yeah, one of the things they want to talk about is more targeted therapies. By more targeted therapies, I mean, generally, they want to talk about specific biomarkers, genetic biomarkers that would be of interest. That's why people are talking about lung cancer, you hear EGFR, talking about breast cancer, especially along germline mutation, you hear BRCA1 and 2, you hear the ESR1 genes, you start hearing things like this. These are biomarkers. So that's one of the major topics of conversation. In addition to that, they also want to see how can we catch cancers early, right? We don't want to be catching cancers at stage 4, as Dr. Lucy mentioned, right? We want to catch cancers early. And the other topic that most oncologists, pathologists would also want to focus on is how can we really make diagnosis of cancer or monitor treatment without necessarily being very invasive, without probably doing tissue biopsies, allowing the patients to go through surgery, right? Maybe from the blood samples, we want to maybe isolate these mutations and help these patients without really opening up and getting the tissue samples. We're not there yet. I know there's active research in that, and it's actually a very long conversation. But these 3 major areas, that's what most persons would be interested in to really talk about. But I'll focus more on the first one because it has huge relevance, especially towards what we do and what we hope to achieve in Nigeria. Next slide. So, okay, so talking about biomarker testing, really, to show that biomarker testing or identifying some of these specific mutations is really growing. Previous slide. Yeah, the number of biomarkers really, yes, keeps growing. Yeah, keeps growing. That's the number of biomarkers like EGFR, ESR1, KRAS, BRAF, things like this you've heard about. It keeps growing, especially both in the US as well as in Europe, from past years. Yes, from say 2022 to 2025, you see that the number of biomarkers will keep increasing, and now even in 2025 there are over 36 biomarkers available. And it's not just the biomarkers, the therapies specific to these biomarkers also keep growing. The specific gene therapies or biomarker therapies keeps also growing because we know cancer is a disease of the gene, right? Mutations would eventually cause cancers. So if we want to treat cancers effectively, we want to really target these mutations, and that's what we're going to talk about today. Next slide. Yeah, and in the treatment or in the identification of these biomarkers, 2 major methods are being done. One of it is single gene testing. My colleague Uche talked about it a bit. With single gene testing, what do? We say, okay, for example, say, let's use lung cancer or colorectal cancer, for example. There are certain specific biomarkers that oncologists would be interested in, as well as pathologists would be interested in when we talk about colorectal cancer. Say biomarkers like KRAS, BRAF, NRAF, and the likes. With single gene testing, what happens is, okay, we'll get the sample, and then we'll start the first set of tests. We want to see, does this patient have mutation in, say, KRAS? Oh, KRAS is negative, let's move to the next. Does this patient have mutation in BRAF? And then you keep moving to the next, doing trial and error until eventually you get one specific mutation, and then you now ride with that. So what challenge does single gene testing pose? First, we'll face the challenge of insufficient sample material, because by the time you keep getting slices or sections of this FFPE, these precious samples, you find out that you've gotten the first maybe few sections, and you didn't get what you want, you move to the next. We stand the risk of losing or having insufficient materials at the end. And then we're having complete testing. What if the patient has multiple biomarkers present, and as soon as we say test KRAS and it's positive and we stop there, what if there's also mutation in, say, BRAF or NRAS? What happens? Incomplete testing. Then there's also long time to treatment, right? We would do the first and then move to the next and keep moving to the next. But with next generation sequencing is actually massive parallel sequencing. We're not just looking at single genes, we're looking at multiple genes at the same time. Find out that we have one workflow, we get the same set of sections alone, we've extracted the DNA, and then we'll sequence it. We have one sample, as well as analyzing multiple biomarkers. At the end of the day, we can identify 2 or 3 mutations present. Next slide. Yeah, and to show why it's also very, very important, I would say there's long time to testing if we're doing single gene testing. But with massive parallel sequencing or next generation sequencing, we would stand the chance of getting results faster. Why is getting results faster? We see the graph here, and maybe you can click on just one more click. Yeah, we see the graph here. It's showing that within just 6 months, about 15% of patients would already succumb to the disease. So we need to actually identify these biomarkers on time, because in 6 months, some patients can progress from stage 1 to stage 4, and then we'll be struggling to manage these patients, right? And that's why we keep pushing to see if we can have early testing, especially with next generation sequencing. We just get everything and then start gene therapy at once. And that's what the other column is also showing. It's showing the percentage of patients that are treated before molecular testing is available.
Physiology in school, and the first topic was homeostasis. So we are going to the homeostasis right about now. Apologies, we might not be able to do the citations that we were doing earlier, and it's for paparazzi. Please forgive us. Over to you.
Hello, good afternoon, everyone. It's a privilege to moderate this second panel or final panel session, and we'll be discussing on the driving innovation in life science research in Nigeria. And quickly, I'll just call on our panelists. I would discuss and share ideas and rub minds on this topic. Firstly, I'll call on Professor Tatfeng Mirabo. He is a special one of mine. He is the Dean Postgraduate School of Dental Delta University, and also the consultant for molecular biologists for Kachi Genomics and Forensics. Then I also call Dr. Bamidele Mutiu, who's also the director of Lagos State Biobank. We also kind of know each other a lot. You're welcome, sir. I also call Professor Emeka Ewela, Director, Capit Ace Covenant University. You're welcome, sir. And we also, unfortunately, Dr. Olaimi is not available today, but she's well represented by Dr. Fred John Obiajulu from Medical Director of Seba Lancet and Senior Pathologist of Seba Lancet as well. Finally, we're going to call on, Finally, we'll call on Uchenna Rom, GSD Account Manager, West Africa for Temple Scientific. It's all men. It's a really... Yes, quite balanced. The only lady in the midst of wonderful men. Okay, so, disease threats and all. So my first question will go to Professor Tatfeng. So what are the most critical areas for innovation in life science research in Nigeria today?
Thank you. Good afternoon, everyone. And good afternoon, my co-panelists. I really want to state that I'm quite elated, to be here, coming from the back end of the country, right from Bayelsa State. Yes. Looking at your question, I think there are quite a lot, to do when it comes to life sciences. There are several challenges actually that we face in our universities. I know Prof. earlier talked about the issue of curriculum, which I quite agree with him, but I want to disagree on one point. Yes, NUC actually started it right, but I believe at the end we all got it wrong, because in the CC Mass that they proposed to Nigerian universities, we were asked to developed 30%, containing the local content, while the 70% was made by the central board, which actually defeats the purpose of the curriculum. I know for many of us here who are in the universities, we really frown at it, and a lot of us actually believe that the curriculum became a bit weaker than what we had before. Secondly, the issue of continuous program development for academic staff, it's something I really want to hammer on. And I believe CACHI has taken the lead because there is a kind of collaboration between TED Funds and the CACHI to train university lecturers, technologists and laboratory scientists on the latest development in the field of life science. And I remember last December we had 2 cohorts, where about 50 academic staff and technical staff were sent to us to train at CACHI, and that was actually a successful outing. But the next point I want to make is on the funding of research by Africans. Why am I saying this? Because Professor Omolabo will testify to what I'm saying here. Severally funds given by foreign partners are to meet their needs. Hardly a result of researches we carry out in Africa when funded by our foreign partners meets our need. For instance, going back to COVID, where we did a lot of work, you are all aware that the genome of COVID was sequenced here in Nigeria. Upon all the funds that were released, almost 98% of the funds were returned to the West because the equipment came from them. They gave a grant running to the tune of some million of dollars, but all the sequencers we bought came from them. The consumables came from them, and the product of the research still went to them. Went to them for them to develop maybe the vaccine or whatever they developed. So they gave us money with the left hand and collected it with the right hand. So I think it's high time the African government start funding research to solve African problems. Yes, I also want to speak about collaborations. Yeah, when we talk about collaborations, obviously I'm doing collaboration between universities, 2 universities, which is actually very absent now. I'm behind the country down by Elsa State, and we have a molecular biology lab. Maybe there are other molecular biology labs here in Lagos, but we don't have any forum where we meet and discuss what we're all doing. So I think we first have to network amongst ourselves, universities to universities, I think we have to look at that. And the universities with the industry and the private sector. I really want to appreciate Dr. Kate for starting that because, I mentioned earlier that there's already a collaboration between CACHI and TED Fund to train Nigerian academics, laboratory scientists and technologists, on the cutting edge technology. For want of time, I want to be very brief now. We actually have to think from the university angle to educate our politicians. We should not only join them when it's time to go and rig for election for them. When they're sending us to be returning officers and helping them to rig election, we should also find time to educate them about what government can do for universities, how research in universities should influence policies and laws of the land. I think it's high time we start thinking about it because severally we stay away from the political class thinking that they don't like us or they won't understand what we are talking about. They are quite knowledgeable, I don't want to, to share this experience with you. At Dean of Postgraduate School, I decided to approach the State House of Assembly in my state and asking every member of the House to establish a chair in PG school to fund a research, from their constituency, and that grant must be won by a child of that constituency. And about of the 37 of them from Bayelsa State, all of our agreed and have established a chair of 5 million in the postgraduate school in my university to help them fund research from their own, in their own constituency, and those research will be carried out by children from that constituency. I think it's high time we start educating our political class. We should not be afraid of them. We should not think they don't know anything. These people are quite knowledgeable and they have the money. And if we don't educate them on how to spend it, I'm sure they will fund research. Thank you.
Thank you very much. So, you guys very, very educative, and I was going to talk more on policy reforms. But before we go there, I want to ask Professor, basically, Prof was talking about investment, and he said during the COVID period we had some challenges in funding more investment into life science research in Nigeria to drive innovation. Looking at the present problems where right now fundings are quite tight even from the international areas. So I want you to throw more light on that, sir.
Thank you very much. Let me also join others to appreciate Kachi and Tamo Fisher for putting up this platform. And I want to appreciate Dr. Issa for her passion, especially even in encouraging funding, for research. I've had, some private discussions with her, and all her plans to see how she can mobilize funding, from the private sector to ensure that research is supported in Nigeria. We need to appreciate her for that. If you listen to her, in our opening speech, she talked about, individuals who have private jets, selling their private jets to bring money to support research. That's how passionate she is about funding research. So back to the question. For us to be attractive for funding, we need to do the science right. We need to do the research right. We need to identify research that can make impact. A lot of us in the academia will just do research for the fun of doing research. At the end of the day, it ends up in publications without making tangible impact. We need to walk behind, identify the needs in the society, in the industry, go back and design research that can make impact. That is one way the industry can be attracted, and even government to begin to fund research. Secondly, we also need to build capacity. Because if you have all the wonderful equipment from Kachi and Tamo Fisher, and you don't have capacity to use them, it will just lie there and be wasting. So we need to begin to build capacity, especially for the younger ones. In my center, being funded under the World Bank ACE project, we have to give scholarships. We have to pay stipends in order to attract, postgraduate students to come and do research. We have to offer them stipend. We have to pay scholarship to ensure that they come to get capacity building. Also, we have tried to build capacity for even medical doctors. Dr. Dunsi talked about research. A lot of medical doctors are now interested in research. So at our center, we have organized what we call short courses, whereby we train medical doctors on genomics research so that they can understand what it means to know the genomes of their patients and begin to apply targeted therapies and precision medicine. Also, we have done a lot of impactful research. Some speakers mentioned about prostate. We have done a lot on prostate cancer. At our research center, I can tell you for free, we have been able to identify some unique molecular biomarkers for prostate and breast cancer patients in Nigeria. We are still at the biomarker level, but we tend to take it a step further by looking at how we can develop these molecular biomarkers into point of care, diagnostics that can be used for diagnosing breast cancer. And also to be also attractive for funding, you also need to get funding, mobilize funding, because funders like to see whether you have been funded before and how you did well with the funding before they can bring in their funding. Okay? Like in our center, we have funds, but we have been able to mobilize over $300,000 US additional funding, coming to the center to support research. And then we need to encourage innovation ecosystem. We need to provide grants, like I mentioned before. In our center, we have what we call seed grants for innovation. Okay, whereby we give the students, not faculty now, because the students are younger, they have the energy, they can do the drive. We had to give some students, I think about 6 of them, each of them $2,500 to try their hands in some innovative projects, and we received proposal for them, evaluated it with the industry to make sure that the research is impactful. And I can tell you for free, the students came up with very good results. So we need to make the entire landscape, attractive for funding, building capacity, attracting funding, doing impactful research, and also collaborating. Okay, because for you to do innovative research, it has to be multidisciplinary. No single discipline can come up with innovation. And the research boundaries are breaking. Okay, the biochemists can work with microbiology. Like in our center, we have biochemistry, we have microbiology, we have computer science, we have engineering in our center. All of us working together, to see how we can come up with innovative solutions. Somebody may be wondering, what is the computer scientist or engineer doing? Like Dr. Issa said, initially, we need to start doing things for ourselves. When we got these grants, before we used to send out our samples for sequencing abroad, South Africa, to sequence for us. But when we got the grant, I insisted that we have to set up our own labs. We're able to set up 7 well-equipped laboratories. For now, we can do our own sequencing in-house. So in case you're a researcher here and you need to do sequencing, you're welcome to our lab. We can do sequencing of genes. Another thing we noticed that was a gap, I think Mr. Chago mentioned it here, bioinformatics. Bioinformatics, we had to set up a postgraduate program on bioinformatics. So in case you have a challenge in bioinformatics, you can sign up for that program. I'm also advertising my center. I'm the town official, okay? So that was another gap. And another gap we identified was taking our genome sequencing to host them abroad. Because most times when we find out new sequences, we deposit them abroad in their own platform. But at our center now, that is why we brought the engineering people and computer science. We now have our own platform, AI enabled, okay, where we can deposit our own genome sequences. We don't need to host them abroad because we don't know what they're doing with us. So on that note, I want to stop there. Thank you very much.
So this question is for Dr. Fred. I know Professor Well was talking about collaboration. I know you come from the clinical sector. So how can we collaborate to drive innovation? Like you said, it's not just one person. It's not just one, one particular industry. It has to be us coming together, collaborating. So how can collaboration help in driving, innovation in life science research?
And as Dr. This is pointed out, it's important that the academia and people from the clinical work together. And it's important that when we are training medical lab scientists, doctors, we impact the research ethics on them and how to do research. And in other countries now, understanding that gap they made it so that you have the doctor, looking at the doctors, you have an academic consultant and a clinical consultant. So the academic consultant will go ahead to have a PhD and just put in my name that. So we have a PhD, then you can also have the intellect to understand what is the research part is doing for you to even implement. You don't understand the research part of the work. If I sit here as a consultant, I don't know what is BRAF, NRAF, so you're talking, I can't implement it, I can't even advise the patient what you need. So I think the curriculum of training of medical lab scientists, doctors, and all of us working in the health sector should be modified that, yes, we have clinical consultants, clinical, also I call the scientists in my university, we are not a medical lab scientist, we are clinical scientists, because we are dealing with human sample. And the clinical scientists working in the clinical setting should have a different mindset from the medical lab scientists. In the sense, you can be able to understand the implication of what you are doing in relation to the patient sample and the patient. So connecting the research with the academia and the industry with understanding of the person using that is very, very important. So I advocate that from STEM, as Dr. Kate pointed out, train our children to pass through that process. Again, making sure that the scientists, the consultant have an academic profile they can relate to understand all this we are saying. Because if you don't understand, you can't even advise. You can't even know what you're looking for. You don't even know the equipment. You don't understand it. So we are just talking. So it's important that this is advocated so that consultant, clinical scientists can go ahead and have a research and then still work in the clinical environment to be able to interpret it. Another important area of innovation I think is important. I go to the industry. When I was in the UK, they stayed there and put the facility inside that place. As much as there's a private sector participation, government, but some of this, your industry, they devote time to put this facility there. You can expect them to pay in 10 years. You can't just give me an equipment of $22 million and say, okay, you pay in 1 year. It's not possible in the environment. So you should find a way to hosting, you can host hemato-oncology, still hematology, go there, take hematology sample. Lymphoma, go there. If you want this, go. We can be able to put it in compartments so that even the industry can know how to support. We can't do everything at the same time and it's going nowhere. So the facility can say, all of us are banking our breast because there are a lot of tumors to even look at. So let's just try having this together. You have your expertise, hematology. We stay there and do the back for hematology. Everybody should be there. Breast, everybody should be there. And all of us will have a little bit share, 1%, 2%, everybody will gain for whatever contribution. And it is helping everybody. The industry can key in and also help to know where to give the right support. Because at times they don't know where to even give the right support. I think I will talk more about
Thank you very much, sir. Thank you so much. Really great. So, Dr. Michiu, I'm going to, because I know we've attended some public partnership workshops before, and I know we've been talking about policy reforms. So, what policy reforms can actually support innovation for life science research? Because I think this is very important. Looking at from the example he gave, going to the State Assembly to fight for, those grants for those for indigents to be able to carry out their research. So what do you think about what policy reforms are needed to support innovation?
Thank you very much. I want to appreciate Kachi for the platform and Thermo Fisher. I also want to appreciate everyone on the panel. Let me first start from the biggest biobank. It's a biosafety laboratory with a biobank facilities. And it was when we look at what happened post-Ebola, we did, we assessed what our response during Ebola, even though everybody all over the world was pressing the Ebola because it very well. And we came up with with some actions. Action point number one, that we must have a diagnostic facility that within 24 hours, no matter the disease from wherever it's coming from, we must be able to give diagnosis. For Ebola, it took us 72 hours for us to have confirmation from IP Dakar. But for COVID, within 24 hours, we were able to do it in Nigeria because we were forward thinking. That's an example of policy. Governments having a buy-in, knowing fully well that for every outlook, for every life science, for every research that they're going to do, there is the economic aspect of it. For Ebola, the economic impact alone was about $1 billion that Lagos lost over that period. For COVID, January of 2020, the IGR for Lagos was 44 billion naira. By April, it was 4 billion naira. So definitely, government knows they have to make policy. I'm in an opportune position because I'm from the academia. I also work in the hospital. I'm also in the lab, and then I'm also in the policy aspects. So I'm able to have what I would call a board eye view of every other of every aspect. So several times what we do is that we develop the policy. I would say this is what we're going to do concerning life science. We first started with, when we started COVID testing, it took us a lot of time for us to get the results to the patient, but we just look at it, brought young minds together, and we said we want to generate the result and get it to the main bosses of all the clients, and we're able to do it. And along the way we said, let's just scale up. How do we scale up? We need to bring the private laboratories, and then we brought them in, and we made them to see that policy can be changed at every given time. Policy is malleable, policy is not static. So, in as much as the policy that we develop is not static, it is malleable, it is adaptable, then you always have to buy it. So the first thing that we must have policy that is adaptable, depending on the situation at hand. Then another thing is that if you have policy that we want to train people in life sciences, you have to go to the industries and tell them, in 4 years then we're going to graduate 50 graduates from life sciences, create positions for them to work. So those people in the institutions will know that in 5 years time, when I finish when I finish my studies, there are jobs waiting for me. But if there are no jobs waiting for them, they are not going to go into life science. So policy must be there all the time to say, industries, these are what we need in the next 5 years. We are going to train those people, but be ready to absorb them in. And that will also solve the issue of, people living in Nigeria to go elsewhere. And because once I know there's no future for me, I will go to another place. I've never had to leave Nigeria at any given time because I know I'm always relevant at every time. If I go out of Nigeria, because I'm attending conferences, maybe because I love Amala. I cannot miss my Amala and the way to so I must always come back home. So the policy is very, very crucial. And it means we create the first from the university, we tell them this is what we want you to be doing. The another part of policy is that for every research you are doing, don't hide it within journals. I was at faculty day in Union Lagana, I told them, for every of your researchers, have you ever gone to the ministry and looked for the desk officer that is related to your field and have one-on-one discussion with them? That the way to have one-on-one discussion with them, once they have any challenge, they will come to you. I never got into the ministry because I wanted to go into the ministry or because I knew people there. Aside from the fact that I was able to make 1 or 2 contributions, then during Ebola outbreak, I volunteered. So for every outbreak, the commissioner just said, get Dr. Until. So with that, I was able to make my impact. So we should, all those who are in the research institutes and the rest, you need to come out. Let people know what you are doing. Even if you, after publishing everything in the journal, just have a meeting like this and say, these are what we have been able to do in the past 4 or 5 years in our facilities. And luckily, he's from Bayelsa. The visit, we were together from ICIT last year, and we discussed a lot. So I was invited to Bayelsa, but I've not been able to come over there. My closest friend is also there. But Lagos State World Bank, there's no level of diagnosis that we don't have. I'm from PCR, able to sequencing. I have myself, I also have NGS. But how many people are aware of that? Those are things that we need to be saying now. We need to blow our own trumpet. Until we start pressing ourselves, nobody will press us. And that is where we are lacking in Africa. We don't blow our trumpet. Yes. But wherever I get to, I always tell them, I don't call myself Dr. I say I'm Mutiu. So they always wonder, why do you say Mutiu? I said, because just Google Mutiu I'm doing. And so they all look at me, oh, this man is, I thought I'm a short man. But my reach is so long. So we need to create a policy and train people and create employment opportunities.
Thank you so much. Very, very informative. If we do not blow our trumpet, how do we identify the issues and how do we provide solutions? It's like we come together, we all share what we're doing and we're able to, when you share something, people bring in different perspectives and we're able to grow and move that from this next stage to implementing solutions. So my final question goes to Uchenna. How can digital technologies best boost life science research in Nigeria? Dr. Fred talked about, the collaborations between the clinical sector and the academia, and also talked about, technologies for research, IVD. So how can digital technologies boost life science research in Nigeria?
I'm going to join everybody to say thank you. Thank you for being on the panel. And the panel of people who have done a lot more things than I have. So that is very interesting. But to answer the question, so life science in Nigeria is at a very interesting stage. See, we are at the point where, as a country, we are conscious that it is important. If there's any curse and blessing COVID gave to us in Nigeria, that's what it is. We lost the Secretary to the Government and Federation, which brought to fore how important it is to government to make these investments. It also helped even people in the markets to understand what role science plays. Everybody knew what PCR was overnight. They didn't just know the name, they knew the full name, they knew what it did. So we're at that stage. So what we then need is the momentum to leapfrog. So we need to jump from where we are to where we aspire we want to be. And a very important way to do it is for us to leverage centers of excellence that we already have. And it's not just, they're not just centers of excellence in that World Bank has called them centers of excellence. They're actually doing really very excellent things, right? There is CAPIC and what they're doing with cancer. There is Professor Hafiz ESG and what they're doing with infectious diseases. There are centers in Enugu and what they're doing around small lung cancers and other viruses. We need to leverage all of those partnerships. And just to re-echo something Professor Catherine mentioned about working in silos. See, at the moment, we're all working in silos. Camrate is doing Camrate in Sokoto. Polio lab in Maiduguri is doing that thing. There's another polio lab in Ibadan that doesn't even communicate with the polio lab in Maiduguri. So, we need to leave those silos. We need to create opportunities for us to have those conversations. If we have those conversations, it does two things. First is, it helps us understand what our real gaps are. I'll give an example with, we've talked about oncology a lot today. It's interesting. So, an example with that is, we used to have a gap with finding treatment centers. Then Master Ruth came around. So that's not the gap anymore. So the new gap is, we're not diagnosing in Nigeria. So there's a problem with lead time between diagnosis and when the doctors. So we need to then fill that gap. See? So that we can identify. With infectious diseases, what COVID did was first say, we don't have the labs. Now we have the labs. Now the problem we are facing is, how do we use these labs to surveil for the diseases so that we are aware of the diseases and they break out on time? The NCDC too has made a lot of progress with this. Now every 3 months we hear about the cholera outbreak. Before we didn't used to hear about them. We just hear some mysterious disease has killed 54 people in Kano. So that's what the news cycle used to be like. But now we're able to identify it's not mysterious anymore. It's not witches and wizards and nobody's doing it. So we need to leverage all of these. First, the partnerships with the institutions we already have. Second, we need to create avenues for ourselves to communicate, then identify the gaps that we really have and start to fill those gaps. And we need to fill the gaps in such a way that we're filling it strategically and we're not just duplicating efforts. Because with duplicating efforts, what happens is that for all of us at Thermo Fisher, it then becomes a problem, right? Because now we have 500 different instruments with the capacity to run 96 samples at the same time, and none of the 500 different labs is even getting up to 10 samples per week. So that's why, like Fred said, we find that in advanced economies, the way they love to call themselves, they have specialized institutions hosting different settings, different things. And the reason is the specialization comes better experience, better resources, and all of those things. So we need to get to that point where we can say, for instance, that at the Lagos Biobank is where we want to run all infectious disease samples coming into some area of Nigeria, maybe neighboring country, something like that. And then we then decide for cancer, we want to do it at NICAT, or we want to do it somewhere. So something like that, what we need to do.
Thank you so much. Uncle, if we have just 1 or 2 questions from the audience, so that we can, okay.
The Center for Human and Zoonotic Virology. My boss is Professor S.A. Omilabu. Okay, so permit me to quickly share. I did read a book in my secondary school days, Jurassic Park. I remember a Dr. Wu. So they engineered these dinosaurs to be lysine dependent. And it was a biological, safe fate, but it failed eventually because what they didn't figure was that when the animals escaped, they had access to lysine-rich food, whether it was herbivores or carnivores. They found a way to feed. Sorry to say, but I see some parallel in companies that build in dependencies in their equipment so that customers don't leave them. I just want to implore, we are talking about driving innovation, okay, in research. For Africa, we are a unique market. And I think that companies like Thermo Fisher could begin considering removing some of those codes in their machines that keep customers helplessly dependent on their products. Why do I say this? Because these customers know that there are other platforms that, for instance, don't require annual calibrations or still perform optimally. And after some time, you find your equipment lying there. They haven't told you that in the period that your equipment is not in use, that they've not been doing anything. It means that you are losing out on the sales of consumables, sales of reagents because of this gap. So you would probably make them more dependent if you opened up a little bit and allowed them to use their equipment for longer with little or no calibration. Because this is a challenge for me. I'm an equipment person. Where I work, we have Thermo Fisher equipment too that we can't use because we can't afford, this. I have a question for you, sir, Professor Iwala. I really enjoyed, your comments on the panel. I also want to thank all those who have been on the panels today. And my question is concerning sharing African data on, public databases. I heard you say you now have your own platform. And my question is to understand where open sharing meets, protection of intellectual property. Because in driving innovation, we're also encouraging sharing. It would be interesting to know whether your platform is closed or open. Thank you, sir. Thank you.
For us, the deposits our genomic sequences there. Closed in the sense that for you to have access to it, you need to have some kind of approval, before you can have access, to the platform. So that is how our platform operates. Thank you very much.
Okay, so just the last question.
Yeah, so
Okay, hold on.
To just talk about our platforms, right? A lot of Thermo Fisher's platforms are open. Right? We primarily do not sell closed systems. The only set of systems with Thermo Fisher that you would consider closed, in quotes, are next generation sequencing platforms. And the reason is because of the way next generation sequencing works, right? And it works in such a way that the technology itself is very different. So when we say our next generation sequencing technology is ion torrent next generation sequencing technology, it literally is defining the method of detection of the nucleotides. So if you take live preparation reagents or other tools that you're getting to detect from other samples, from other systems, and bring it to use on our system, it doesn't work because there are two different detection methods. So it's like taking a key and trying to open the wrong door. And if you take our reagents and do the same thing on a separate NGS platform, it also doesn't work because the technology for detection is very different. And you can also see it in the quality of the results you get across NGS platforms, where people tell you, oh, our error rate is 15%, and we at Thermo Fisher brag that our error rate is around 5%, and then other people have much larger error rates. So that is probably the only place where Thermo Fisher is a closed system. And that's why. For every other technology we have, starting from where Koweli had given examples of PCR instruments, even though our recommendations are that you continue to use our plastics because, one, we love the money, two, because we can vouch for the quality of the plastics. I'm very sure a lot of you who have used our PCR instruments do not buy plastics from us because we know we don't see the revenue for the plastics, which means the instruments have been working fine without using our plastics. So, and then for calibration of instruments, I imagine this is around our qPCR instruments and maybe our sequencing instruments. With sequencing, calibration is extremely important because we need a baseline. If we don't know what the baseline is, we cannot then say it is adenosine here or guanine, or we can't do that. So every sequencing platform is going to require calibrations. Anyone that tells you they don't require it are doing something criminal. Then on the qPCR side of it, right, we advise again that you calibrate the systems once a year. You can use the systems without the calibration. It will work fine. But the difference it creates is we provide what we call a Tachman guarantee, right? And the Tachman guarantee is saying if your instrument is a Thermo Fisher instrument, calibrated up to code, and you use it to run anything, take it to the moon, you should get the exact same results. But when you don't calibrate it, you leave it at you are the same way every other instrument is. There is no differentiation between what you are doing, and there's no way for you to validate what you are doing. And as scientists, one of the very first tenets, other than the scientific way of thinking that they drill into us, is to have controls. For everything we do, we require control. If our instruments are not calibrated, we can't effectively say we are controlling the reactions that we're running on them. So yes, it is true that there are lots of instruments that do not require calibration. It is also true that our instrument would work without the calibration, but it's not really the best standard to go about doing all of those things. But on a broad scale, all of Thermo Fisher's instruments are open systems. Thank you.
Thank you. Dr. Walker.
Yeah, good afternoon, everyone, and thank you for the equipment will be designed according to what will suit us. Biomarkers will be designed according to our own genes. And our children in the primary school will be able to visit you and then do IT or holiday beside our company that is in Nigeria, owned by Thermo Fisher for Nigerians.
It's a really good question. It's a really good question, and we don't take it for granted. As market leaders, what we'd also try to do is to provide some level of thought leadership to shape the direction of where we want the market to go And it's not just in what we want to sell, it's also in what kind of solutions we want to bring to the market. What do we want to see change? We try to identify this a gap, and we try to say, okay, who do we work with to fill the gap? It's not always very easy to fill a gap. And with what we are doing so far, some of the things we have tried to do, even with the Presidential Committee for Business Enablement, PBEC, right, is to see, first, we do need local partners, and we have beautiful local partners. And as you said, well, polygamous. But we're not going to establish a company in Nigeria in the next 5 years. That I can tell you. Will it happen in the next 20? Maybe. Are we working towards it actively? At the moment, what we're trying to do actively is to make sure that the quality of research that is being produced or the quality of care being delivered in Nigeria is at par with what you'd receive or find anywhere else. That's for us what the priority for the next 5 to 10 years is, at least for 4 of us sitting here. If there's a lot of local content, right? There's a lot of local content. One of the very important parts of local content is when we work with catches, for instance, we train catches engineers, we train catches scientists. It's a lot of skill transfer. So it's like, in effect, when you have a maintenance contract via catching for a Thermo Fisher instrument, the catch is acting as Thermo Fisher. That is what it is in effect. So in that way, we are transferring local content. You've heard Dr. Kate say she's going to start to manufacture certain things. In doing those manufacturing, it will require a lot of support from us. That would include transferring IP from Thermo Fisher to them to do all of those kind of things. So yes, we are doing some of it, and we're not doing some of it. But the overall goal is for us to see that we can address the immediate challenges you have, and we can address the challenges we come up with you to say will be there in the next couple of years. And I hope that someday, sure, you can come do some IT with us. And just to also say something is, we do have grant applications that you can apply to. You can apply for a Thermo Fisher grant. One important one we have running every year is one for cancer. So we have an Oncomine, grant running every year, and in this way, you can just apply for it, get selected, would fund whatever research that it is that you're doing in that way. So that's what we do so far.
Thank you very much for the beautiful answer.
Question seems to fly in the face of what we're trying to do here, and that is to get homegrown solutions for our needs. Not to sit and wait for someone to come and do it for us, but to actually begin to do it for ourselves. Yes, with their support. Yes, with whatever support we can get. The support we will control. I hope the fund, the grant, will allow the research people to keep their information.
Yes.
They're not going to give it away to anybody.
No. Well, so
it's not going to be controlled by anybody else. It stays here.
Yeah.
What happens in Nigeria stays in Nigeria. So what I want to say is they are already doing the things you're asking. The first, in fact, I was at a meeting, thermal dealer meeting in Dubai many years ago, and this man, Tom Blanket, said to me, Kate, we're looking to set up a demo lab. We're looking to locate it in Ghana. Nigerians will come to Ghana, you bring your customers to Ghana. I said to him, Tom, set up a demo lab in Ghana for Ghanaians. If you want Nigerians to come to your demo lab, it has to be located in Nigeria. If it's not in Nigeria, we'd rather go to Dubai to see your demo lab, or Germany than to go to Ghana. And we're one of the very few dealer partners that have demo lab. It was with a lot of support from Thermo, from Merck, that we're able to get what it's been there. It was, in fact, when we started talking about demo lab, we told, what's that guy's name? Not Christian, no. Sorry, it's not Serge. So Serge hated us. Serge took our business and gave to No, Serge wanted to shut us down. It's the grace of God our relationship with Samo. What's the guy that?
Antonio.
Roberto. No, it's not Roberto. Rashid, the person that helped us get equipment. All those ones to us. He goes, but kids, don't allow us to have the newest equipment. So for it to be a demo lab, it has to be cutting edge. It has to be at the top. He says, I'm going to help you make it work. And he did. So he gave us the best. You know, we paid for it, it wasn't free. They don't give anything free. But he spent for us, helped us with Rashid. Everything there was Rashid's people working with Shotman. And we're not government, we're private people. And we didn't have all the money, we just had to believe out my father for it. My father in heaven, that's for me. You know, we have a wheel, you want to go, and you step forward, and whatever you need is provided. You know, it's just, so what I'm trying to say is we cannot wait for anybody else to do anything for us. We need to be doing it. In the new place, you were there when we did the groundbreaking. We're still waiting for my father to complete the money so we can get to where we need to go. You saw the photos. There is manufacturing there. We're working with Thermo Fisher Scientific to support us to produce things that make sense to be produced here. Where the plastics, the media, the shelf life for media is short. But if we blend it here, if we get the powder and do it here, close to use, it extends it, it won't expire on us. For Merck to ship analytical water, think of shipping water, the cost of it. So they're working with us to produce type 1, type 2 water here. So we have to seriously identify products that make sense to make here because our environmental limitations are crazy. You generate your own power, you produce your own water. The government breaks down my wall at the lab and they threaten us and intimidate us to fix it at our cost. So and then you borrow money at 36%. Where does that happen? So the cost of doing business here is so high that if you want to produce the same things that they're making in China, it won't make any sense. But there are some products, like biosafety class 3 safety cabinet. We got a contract to deliver to NCDC, 8 units. We paid this company to produce 8 units during COVID. We were waiting for it to be shipped. We were getting pressured. And they say, no, their government, they have to apply to their government to approval to ship it out. And finally, they came back after several months and we're getting pressure from NCDC, we need these things now. They came back to say that the government, the Chinese government, refused to approve it. They even to approve one, they had our money. And we're going to send it by air, the cost and the air. We eventually were able to find from Singapore. And we're thinking in our heads, we need to get all of the approvals globally to make them here. So if there is an outbreak, we have our own, we're not waiting to ship from anybody. So it's a lot of heavy lifting to get to the place where you can make those things happen. But you want to do it right, you get all the approvals, you do it according to the quality standard. I'm just saying that any one of us in this room can do these things. We don't need to wait for government, and we cannot afford to wait for anybody from anywhere to come and do it for us. You go to different African countries, and I have been to many, and they're all sitting waiting for Igbo to come and do things for them. The only country in Africa you go to, and they're not waiting for Igbo to do things for them, is Nigeria. So Nigeria is the redemption of Africa, and we must do it. We can't wait for government. We'll be going and be dragging them. We'll be going and, wherever they can support this, so we pull the support. We'll be going, but it's up to Nigerians, up to us. So, no, don't ask Thermo Fisher when they will start manufacturing. Ask our research people when they will find the products that need to be produced. We are ready to engage with them, to partner with them, to commercialize it. Thank you.
much, ma'am. At least that one question has changed the scenario of this room, and thank you so much for that. But there's something that is here. If we know the good things that we are getting from the West, modeling, management, designs, and everything, why is it so difficult that we don't have that run in our own system at all? Anybody can help me answer. Thank you very much.
It's also another good question. Yeah, there's so many good questions today, but I'll give an example. There has been no developed supply chains to make them happen. I'll give an example with just how difficult it is to get an instrument that already arrived in Lagos to Maiduguri. Just shipping it from Lagos to Maiduguri takes somewhere around 3-4 days. And this is DHL Express. Then we also have to think that, before we start to produce, she has chosen really nice things where we have, advantage to start from. With plastics, we produce petrochemicals and we produce petrochemical base for plastics here. So we can do that locally. And I think some people do. We already produce a lot of the plastics we use locally, so we can just transfer that to like lab works. But with qPCR instruments, for instance, every qPCR instrument has a number of microchips. Those chips are not made anywhere in Africa. They're made by just maybe 3 countries, and the US is fighting all of them at the moment. Because the US itself is not even making them, right? So that's one. You then need to be able to get the metal plates done to specification across all of them. Well, we have iron ore deposits. We don't exactly use our iron ore deposits for anything. It's the same reason why Nord produces cars in Nigeria, Innoson produces cars in Nigeria, and we cannot buy the cars because they're too expensive. They have to import steel, they have to import the engines, they have to import everything that they use for those things. But if we are able to produce, generate, fix the supply chain problems, and the supply chain is like just to produce one qPCR instrument, probably have 500 different supplier agreements. At the end of the day, when you pay China in yuan, you pay Japanese in yen, you pay Singapore in Singaporean dollar, you pay the US in dollar, the price component of that instrument manufactured, or this time around and assembled in Nigeria, makes no sense on the market value for purchase. And we also have to bear in mind that Nigeria does not have a 0% tariff policy like the US used to before Trump arrived, right? So for everything you import, there's an excise duty paid on it. Even when they have said pharmaceuticals are duty exempt, you pay them more rich. You have to pay something. you don't go away, you have to pay something. So all of these, they are individually, they are small limitations, but put together, it creates a really very difficult supply chain system and makes it hard to manufacture things here. Is why when companies like GlaxoSmithKline leaves Nigeria, it is painful to see them go. Because despite all of these challenges, we have so many businesses that have chosen to set up here and fix some of the manufacturing problems here by themselves. And I don't know if you guys really understand what Madam Kate and Dr. Elibutu mean by you have to produce your own electricity. If you run a lab at all and you have freezers, those freezers can never go off. If not, you lose the reagents completely. And this is something I think Professor Tatwing and I can attest to really well, right? Losing everything. And sometimes you're losing millions, and it's in double digits of millions that you've lost. And you have to go and look for the funding to come back and redo all of them. Then Professor Tatwing, while we were talking yesterday, also said something. We build beautiful houses, but without lightning rods. So every time there is the slightest look of an electrical storm, you lose equipment completely, and then you have to start from the beginning. And one we had to deal with late last year and early this year at Thermo Fisher was the WHO lab in Maiduguri got flooded because our government did not repair a dam that then broke and flooded the entire city. In a city that should never be flooded in the first place, right? And they've lost a lab that costs multi-millions of dollars that needed to be fixed from the beginning. So all of those small problems that we have is why you don't see all of this is happening here. And I'm hoping that we can fix all of them.
Sorry, that's just fine. Can I just say, and I don't think we're going to fix all the problems in one day. I think that all of us, but one thing, I don't know about everybody else, and nobody's paying me. I came on my own. I came on my own, but I'm so, honestly, even the last thing that you just mentioned now, they lost a whole cancer hospital with linear accelerator radiotherapy machines in Maiduguri from that flood. And nobody is saying anything about it. But I want to just say that, just everybody in this room, bringing everybody together. I hope we don't lose this. I think going forward from here, whatever else happens, somebody needs to, there has to be some, I don't know whether you want to call it an association of molecular biologists or innovation or something. There has to be, because I'm sure that, as you said, the people here who haven't spoken to other people, I, for example, I mean, even though I have some relationship with Covenant University, to meet you, sometimes to say, this is how we're going to make this thing happen going forward. We have to come up with a group that now meets on a regular basis, where your students will present this data. Prof, you were talking about it, how do you not monetize, commercialize, and even take the work that you're doing into clinical work or into industry or whatever, where you will then get the grants because it will be to the benefit of industry to make that happen. Please, and I'm not putting my hand up because my plate is more than full, I'm going to declare that. So please, through this, there has to be, please, a way that we can have these meetings twice a year, is fine, which means that this connection, these discussions, I mean, I really enjoyed learning about that. I'm sure there are many that have happened before, right, that didn't last. I mean, when I started, people told me, tumor board, you're going to have a tumor board every week to discuss our new patients with doctors abroad. So many people have tried it before. I came to some meeting here, some pharma company, they told me prostate cancer, we have been to all the teaching hospitals, they will start the tumor board, after a few months, it will disappear. We have run a weekly tumor board since April 2021. We have never missed 1 week. True. And we still have 6 people, we're all Nigerians, I'm very Nigeria-centric, I don't have any expats working with me or for me, that's for sure, right? Till tomorrow, and I was told that it will never happen, that so many people had tried it before. We're doing this on the back of Dr. Isa, Dr. Kate Isa. You know that nothing she does doesn't happen. There has to be a connect that with meetings where people either on the technical side, and then also to be discussing the wins that different people, how you set up this amazing systems, how Dean of the, this is amazing, and please, my plea, let's not lose this. Thank you.
Professor it's good at things like that. We volunteer him.
Yes. We will be there to support you.
She will be there.
What's the name? What's the name? No, what's the name of the association we're going to form?
Kachi Research Hub. I'm going to short. Kachi Research Hub. Kachi Research Hub. To make it faster. All right. Thank you. Just to add some few words to what my sister just said, it's not that good things don't come from Europe, but I want us to understand that Africa is the richest continent on earth.
Yes.
But unfortunately, Africans are the poorest living beings.
Yes.
So all the resources, that our colleague from the other side come and tap, convert them to product and give us finished product here at exorbitant price. So what we are just trying to do here is to awake that African consciousness that we can solve our problem by ourselves, as it stands with that. It's so bad that the neo-colonial mindset that we still have, has so much deepened into us that even our own history is written by those never lived in Africa. And that's what we want to set aside. We must take our destiny in our hands. And we talked about transfer of genetic materials. In other words, we call it biopiracy. Many of us do not even realize the extent of biopiracy, because if we have had the opportunity to read the Biodiversity Convention, where it clearly stated that any genetic material tapped from anywhere in the world, any product that you derive from it, the country where that genetic material came from should benefit from the proceed. That is written down, but many of us are not exploiting it. Because if you look at many of these molecules to handle some of these we have, they are from African products. I don't want to share an experience with us. I did a sabbatical in one of the universities in the South. I visited a village where a colleague told me, no woman in this village has ever delivered through CS. I said, what do you mean? He said, you see this grass? It will turn a baby in the womb. Yes. In Akwa Ibom State. He said, you can turn a baby in the womb. I don't know. Grass. And this herb can't grow anywhere. I was with a colleague from Unical. Other things we don't know what they will do with it. So, I think Africans should take their destiny into their hands. Thank you.
Thank you very much. It was very happy.
Please, I think we all have to know that we are not the worst time. COVID has showed us that we're not the worst. Even in the UK, where the high point of COVID, they can't find gloves. From China, I can't believe it. So we're not alone in this. I'm keen into what he said. Start with the ones we can do. No country produces this alone. Even in Canada, UK, Mexico brings one part, Canada brings one part, Dubai brings one part. Bring what part are you contributing? So nobody has it all. Even in those countries who think they have everything, they still have their own challenges. But somebody is helping. We never knew that we can have our crude oil refined with all the share and chevron until Dangote dared to do it. So the spirit is there.
Dangote wasn't the first one.
Just
Walter Smith was refining long before.
I am just saying. I am just saying that the capacity he went into doing this as a Nigerian. These are the spirits we can tap in because just the spirit I'm talking about. We can drive this innovation. We have all the raw materials to do it. Thank you very much.
Yes, and just to close before you want to say it, on a final note, the important thing is to remember that at Thermo Fisher, our goal and our mission is to help you to make the world cleaner, healthier, and safer.
Thank you. Thank you very much. I want to thank my lovely panelists for this very interesting discussion and for all the contributions and questions. Let's just keep the conversation going. Let it not stop here. Let's collaborate and let's share so we can bridge the gap and implement solutions. Thank you very much for having us, and thank you, my esteemed panelists.
So without wasting any more time, we would like the first 18 sets. So please follow me to the chemistry lab. The first 18 sets.
They are not the ones that come, so as they are coming as one.
All right. Just follow me, please.
1, 2, 3, 4, 5, 6, 7, 8, 9.
That's one more.
Good evening once more. Like she rightly told you, my name is Daniel Francis. So this is for AAS, Atomic Absorption Spectrometer. We use it in the analysis of elementals in our various samples. You see, what we do here is to provide solution to problems that would arise as a result of ignorance, like our samples that we may use as raw materials in the production of several products, may contain some heavy metals. Of course, you know there are some heavy metals that, of which you put them inside of your system, they will cause cancer. They are carcinogenic. So if we want to analyze to find out if such raw materials really contain these heavy metals, we bring it in here, and all we have to do is to analyze the heavy metals. But before we come here to analyze it, we will have to pass through the process called digestion. We have to digest our raw material or whatsoever item that you bring into this lab for the analysis of elementals. There are many elements that we can actually analyze using these areas. Elements like mercury, cadmium, chromium, nickel, name them. There are so many of them, and we have standards. Each of the elements have its own standard that you can use to analyze.
To just round up some of the things, yes, I'm coming to that now. To round up some of the things he's trying to say, because we don't have much time. This equipment cannot be covered through various aspects, various industries. When we talk of the agro business, agro areas, where from your soil you can do soil testing with this. Now, before you plant, you want to check if your soil has nutrients, if it is contaminated or not. You can do that. Now, the water you will use, you need to know the quality of water. If they are lead contaminated, of course, it will either destroy your seed. Your seedling itself, you want to know if they are potent or not, you can do that here. Now, all of those materials that probably you have processed, along the line, some things must have been taken up as contaminants, elemental. Refining industries, we can do crude analysis here, analysis here. Mining industries, you are mining something, you come across stone. You want to check, is this gold? Is this and all that? All this can be analyzed here. Just to summarize, you know. And here you have the parts.
Okay, the AS comes with different parts. We have the flame parts, we have the furnace parts, and we also have the fuel parts. And just like you mentioned earlier, we are here to protect the integrity of whatever results that is put out there and to ensure accuracy of results. And as such, there are different elements that are suitable for each of these parts. So whatever we are using, whatever elements or analytes of interest that we are analyzing, will determine the components that we are going to use. Because for example, this flame now, we can use it for say iron, for this we can use lead. It's not suitable with lead. And for the vapor system, we use it for mercury. We are sure of the results we are getting for mercury when we use the vapor system. And that is why we have these three components together to ensure that we are the accuracy of the result of whatever finished product or raw materials like you mentioned put out there in the market to ensure that it's safe for human consumption.
We can now take any question, like you have a question.
I just want to ask whether you use it for human analysis apart from agro or whatever. Because at times we want to research.
Yes.
We want to check different elements.
We can use it.
Okay, if I want to
we
mention
can use that.
If anybody has a research like that, we can equally bring it here.
We not only work on agro.
So let me maybe I don't know if this will answer your question. So they said getting requests on the analysis of lead
Blood serum. Just yesterday, so we got another one.
So we've been receiving this request of this, so maybe different part of the country, maybe where they have cases of lead poisoning and the like, so they will have to take samples from the people around that area to check the lead content in their blood. And you know, lead being even if they are present, it's supposed to be very trace amount. This is AAS. Apart from AAS, for that sector, we also have IC, the supplement and the supplement. They are doing the same function, though one is much more sensitive than the other. This one can turn up to PPM, even PPB, because it has other techniques apart from the usual flame techniques that we are used to. We have graphite. time, whereas this one measures multiple elements. So apart from the aspect of maybe heavy metals, which are carcinogens, we also have elements that are good for the body. So this is the same equipment that we use to test for them. Yes.
Let's continue. Do you have any other question? Does that answer your question, madam?
Yeah, somebody wants to use it. I've used it before. Somebody need, instead of going to Ibadan,
As we go further, we will be showing you advanced equipment and more advanced equipment, like we have shown you at the tricycle level.
So even though we have big equipment, we should also not forget that we have small equipment that also help us to get our samples in the form in which we can be able to effectively test them and get desired results. We have certification based in the dissolution process, tasting the dissolution of your sample. We have pH, small but mighty. If your sample is expected to be maybe have a neutral pH and you're having that basic or acidic medium, then there is a problem. So we have, of course, for you to say this is this result, you have to calibrate. That is what we've been talking about. You have to calibrate. So we calibrate it every day with buffer 4, 7, and 10. So these are like the pH regions of range of the samples we test on a daily basis. We have transmission titrator. We use it for water content determination. You know there are some samples that we need liquid for. So one of the parameters we need to look for determine the water content. And you'll be asking yourself, this sample is already in liquid, so what are we testing for? So this is the equipment we use. Yeah, we also have our blenders.
We have our blender, industrial blender, for those that are interested in analyzing their solid minerals. Of course, sample preparation is very useful to crush your stones. If it is beans, aflatoxin or pesticide, these are what you use to crush your beans or any solid.
So UVPs, I believe it's a common equipment. Even in life science, they also use spectrophotometer. So it depends on here we handle both research, routine quality control. So it all depends on the nature of your sample and your product. Yeah. So I've talked about this. This is our oven to determine moisture content, while that one is water content, or what we call loss of drying in pharma, because we also handle pharma products. So we have this is flame photometer, similar for elemental analysis, but it is limited. You can only test for sodium, potassium, calcium, barium, and lithium, and in high concentration, unlike all these ones. So when you bring a sample, when you look at a sample, you know what and what the equipment that you will be needing. So for those that will be interested in drugs, because of the seminar, we made mention of BAV and BEV studies, bioequivalent studies. So by the time we commence operations, we are going to be making use of this. In fact, as at today, because in this part of the world, research, drug discovery, we've not gotten there, evolving. So what we find out that what is obtainable now is people analyzing generic products.
It's analyzing the drug treatment.
Analyzing generic products, you understand? So what do? They just do BAB. They do what we call dissolution profile. What do? They pick an innovator brand and analyze it alongside the generic brand. You understand? And establish the profile. They are trying to find out, to be sure that, for example, I have an Ampiclox, Vitram Ampiclox. I will have various brands of Ampiclox in the market. Of course, the price for Vitram is a premium brand, innovator brand. You can't compare the brand. But we'll have to show something, a data to show that this one we have, cheaper ones can as well fit into of the same place. So they end up in what we call the solution profile. That is what we submit to the master. They are part of their product. So that is what. So
that's the so-called bioequivalence.
Yes, bioequivalence. That is what they do now. It's part of. They use it for routine quality control. So each drug, batch they manufacture, they make sure they take it through dissolution. Once it passes, you know sometimes people will be complaining that they take a particular medication and the thing is not working. If it fails this test, it cannot work. So it's very critical.
Yeah. In other words, what this equipment does is limit the body to the human eyes. So when you take the tablet close to this part, this equipment tells you the number of times taken from the tablet completely absorb in the medium. Of course, we have different mediums. Kinetics.
So, Mr. Benule, technical officer, responsible for the GC chromatography lab. So please, can you take us briefly, take us through?
Good evening, everyone. My name is Benule King, and I want to welcome you to chromatography world. So here we have glass chromatography. This glass chromatography is with a flame ionization detector. The other one there too is a gas chromatography. But this one has a mass spectrometer, unlike this one that has a flame ionization detector. So they both have the same techniques and they work on the same principle. The only difference there is that one is more sensitive than others. So I'm going to talk about this one first. This one we use it for different raw materials, pharmaceutical raw materials, or even active excipients and finished products. We also use it for environmental samples. So we use it for testing fatty acid profiling. We use it for impurities checks, maybe internal, because some beverages check for ethanolic concentration of beverages. We also use it for cholesterol. We use it for propylene, ethylene, and ethylene glycol, as in drugs. So it depends on what we are working on. We can use this one. So unlike that one, for us to use this one, we need a standard, a working standard for it. So if we are working on this one, we must have a corresponding standard that will help us to know if maybe whatever we are getting is related to what we are having there. So let me talk about this one. This is GCMS. That's gas chromatography with mass spectrometer. So unlike that one that needs a standard, this one does not need a standard. It has its own library. So everything I run is just going to show exactly. If I'm doing, for example, if I'm running a fatty acid profiling, if I want to check all the fatty acid methyl esters in the oil, it's just going to give me the names of each of the components. So that's the profiling there. So we also use it for impurities. We use it for pesticides. Most of our foods, maybe from agricultural products, maybe during production, during conservation, they use pesticides for storage. So as time goes by, some of those pesticides escapes into the food. So at the end of the day, everything must be checked. And with respect to its sensitivity, it can see as low as parts per billion. So it's very deep. It can, even the minute quantities can see it. So apart from the pesticide, we also use it for forensics analysis.
Yes, for those that are interested, I believe some people are also interested in human investigation. Yeah. Now, this has been known to be useful in determination of the cause of the person's death. That's to determine if somebody has ingested poisonous food or poisonous drink out of death. So what we do here is just to take the blood sample, do some sample prep, that's what you call science in your industry. And because it has a mass spectrum, it's able to identify the known to the unknown, naming it and the particular additive in the blood. In the developed countries, when one is being caught drunk driving, women who go drunk driving test. It's a depends on it tells you the level of alcohol in the blood. This thing is cigarette nicotine. You can use this to determine the nicotine level in the blood. So there are more we can do, we can achieve with this. And we can get those inquiries from you. That's one of the reasons why we're setting up this auction. We know what we can do and how we can partner so that those samples can come here and we'll help each other in this thing. Let's move forward. Thank you. Sorry. This is HPLC unit, and Mrs. Quinn here is in charge of the HPLC. She will take us through what she runs as her system.
Okay, good afternoon, everybody. My name is Gwen. I'm in charge of the HPLC. Like you said, high performance liquid chromatography. You can look at this equipment. We use in analyzing different samples, ranging from pharmaceutical samples, testing for active in drugs, agro samples, aflatoxin, sweeteners in food, even vitamins, the fat soluble, the water soluble. So this equipment has different compartments. The pump, the auto sampler, the compartment. Like I said, like you explained, this equipment uses gas, but this uses liquid. That's why I call liquid chromatography. If you look up, you see different bottles. These are the mobile phases we use. Mostly we use acetyl nitrite, methanol, and water. For adventure, the sample you are testing is not within this. That's where this fourth bottle comes in. That water inside. So this compartment is the stationary phase. That's where the coding is, and that's where the separation takes place. Now, we have two detectors we use for this particular equipment. This is the UV detector, and it can go as long as 4 different wavelengths. And this is the FI fluorescence detector too. So this term is like derivatizer. There's a particular analysis we run at aflatoxin. It's mostly found in agri products like granules, melon seed, many agricultural products, even corn. Aflatoxin is found in them. So when we now run this aflatoxin, it doesn't really come out well. So this derivatizer, it's what it converts in such a way the spectral lines can actually be seen. So this equipment like this, it can do a whole lot.
So let me add to what Ms. Gwen has said. She was making reference to aflatoxin and pesticide. Now, these pathogens, we all eat beans, right? I will come down to a little bit of the level that would understand. There is kokoro inside the beans. Now, when the kokoro has shit inside the beans, we will say when you boil the bean, it will go. It doesn't go. We call it the pathogen, what the kokoro has secreted inside the beans. It stays on. You will bury it and say it will die. It's a lie. When that beans grow, it continues. I don't know if we understand that concept. Okay, you will say, let's give it to the goat or the chicken to eat. It doesn't die. The goat will breastfeed this same pathogen to the offspring. You will kill the goat and slaughter the meat and cook and eat. It is still there. So we need to be able to trace these things in our product. Your pepper, you will see the maggot inside. You will wash it, don't worry, you will boil it, but it is there. So these are part of what we are trying to trace here. Multivitamin, the pharmaceutical industry, is very useful as well.
This is LCMS. What we use it for, we majorly use it for research purposes. And if you look at this equipment and this, they are very similar. But the difference between this and this is just that it's connected to the mass detector. So it has 2 different detectors. It comes with a diode, that comes with a UV detector. This comes with a diode array detector and a mass detector. So whatever is not separating with the diode, the mass detector is able to separate it as well. And just like it has a mobile phase, it has a gas and all that, and we use it for a wider range of samples. Unlike maybe some of the equipment, for example, the GCMS is majorly limited to organic material, organic samples. But this will work on both organic and inorganic samples. And it's also highly sensitive and will detect no matter how small whatever is present in your sample. You analyze it, it will definitely detect it. And one beautiful thing about this equipment also is that it's able to identify your node. Whatever is present in your sample, you can actually scan through. It will give you, from scanning, you are able to detect those peaks, everything that is present in your sample. And from there, you are able to quantify because you run your standard, and from there, from your standard, because your standard is like a basis for comparison to get the concentration. So this equipment will do what we call quantification. It will do for identification and quantification of whatever analyte of interest that you are interested in. So most times we use it for research as well because of the benefit, the advantage of it detecting your node. So we use it majorly for research purposes as well.
Yes. Now, if you have noticed, we have shown you sophisticated equipment. All our equipment are sophisticated, and we've also shown you a more advanced sophisticated. So you have a question, madam? Yes.
Is it the same we use for laboratory quantification and then A1C?
HPLC for hemoglobin quantification? No.
We have HPLC that we are using for hemoglobin quantification and HbA1c.
Yes, you can use HPLC for hemoglobin. You can even use an FTIR for that as well. Because what the FTIR does, when it compares it with the standard, it's able to plot the graph and tells you if this is hemoglobin or if it has been adulterated. Yes, you can do that. Now, like I was mentioning, we have sophisticated equipment and more sophisticated equipment. This equipment, on the whole, can buy you a house in Dubai. That's how expensive it is, and Kachi has been able to invest its resources in life sciences, or should I say pharmaceutical sciences.
So can I know the price of how
Price?
for my year?
Don't worry, we will revisit that. But for this information, this trial, this is what we are doing. This is our water purification system. We know during sample preparation we need clean water, type 1 water, distilled water, and the rest. So this is able to give us the type of water we need to run analysis. Behind you, we have our own gas generator. Like Deborah earlier mentioned, she mentioned that this equipment called gas chromatography uses gas as the carrier pigment or carrier process to carry the sample. Now, because we used to buy gas in cylinders, if we need a gas, say to give them the lights for instance, what the supplier do is they give us whatever it is take underneath and put the original one on top. When the main gas is almost finished, the second will now come and spoil our equipment. It was giving our result. Even sometimes the equipment will start picking whatever it is that is in the fake one, interfering with the result pick that you're supposed to get. But since we got our own gas generator, the results have been fantastic. It is expensive, but at least we are confident of what we are presenting. So please, let's. If you notice, this room is cooler than the rest. Here we have 2 ACs. One runs in the daytime, one runs at night because of this equipment. This is FTIR. A lot of us know FTIR. But this is the advanced FTIR because it has a mass spectrum. Now, FTIR, Fourier transmitted infrared. Yes, FTIR. So what it does is very useful in, how will I put it, discovering adulteration. Now I'll give you some story instances, real life issues that we've been able to solve here. A man saw some capped capsule in the pocket of his son. After inquiring where the boy got it from, the boy did not say. But he had some change, he brought the sample to us. After investigating, we discovered that the major content of that capsule is ketamine. Ketamine is a hard drug that has been rolled off out of the shelf. When you inject ketamine into a man, it's unaware of the environment, falling apart. Now what this FTIR does, because it has a mass spectrum, is able to identify the major content of a material. Also naming those things that has been used to mix it. Maybe let's say I see codeine inside this thing, 85%. I also see sand inside, 10%. You name everything, drawing the graph, you're able to now check if the raw materials you ask them to supply you is real or it's been mixed with something. You understand? There's this company that produces their own Aboniki, radioactive of Aboniki is made to celebrate and make sure. Yeah. Now they've had issues where people went to prison because of this. You understand? Now because they didn't know the store people probably may have changed hands with the supplying the raw material, and when they produced turned to water, until they brought it here, we were able to discover that the supplier had given them refined cassava, tapioca underneath, and the raw original methoxy. What we did is just to put it here, without doing sample preparation like O1 mixed with this and all that. They has made it easy. You don't need to prepare anything. I can cut from your cloth here. There is a spoon here. You put here, and the graph tells you which is which. Yeah. So let's just go direct to this. This is NMR. Nuclear magnetic resonance for research, investigation, and training. Now, I'll give you a simple example so that will explain it. Let's say you have your 5-alive that we all know. You want to produce a new 5-alive. In this new 5-alive, you've added pink color, vanilla flavor, increase the sugar. Now, it is the job of this equipment to tell you, irrespective of what you have added or reduced, it does not change its parental structural limitation as that first one. I have said for investigation, if you want to investigate what is wrong with the old one, produce a new one or replace it. That's what this equipment is for. So can we please go to the next slide? Thank you very much. We're just trying to beat the time. But if you have any questions, please, you can always reach us via network.
sterilize here before going into the sorry.
Lab will fit. If you have the less infection, lab will also fit. So like a broad purpose lab. But for the main,
say your passive.
yeah, thank you. So it was just, you know, when you are modeling, you know, on the old structure, you know, it requires a lot of brain work to come up with something like this. So here, basically, this space we use it for our student projects. Students come here to do some basic work. So we've worked with them here. So then, from here, if we need to move to the application, so we see our task box, take up the serial extraction from the acid index, and come in here. So if it doesn't require, for example, for blood for human identification, specifically we handle it here. So if it's bacteria, we process, pass it here, and roll it out through this task box to the next room. So we are having our automated DNA extraction machine with thermal fission. You know, I think we saw this equipment during the presentation. You know, this is an automated system. So how many samples goes there?
This one 12.
12.
With one control.
With one control over there.
That can be 24.
Okay, 24.
Yeah, we also have systems that do 96. Depending
Okay,
on
the bigger, the bigger one.
Yes, the bigger ones. But this one is strictly for human identification, so it just has one protocol. But this has several protocols because you can extract from different sample types. You can extract from blood, plant, from cell, and it has different times which it does the extraction. But this one uses a robotic system, so everything comes with pre-filled cartridges with the wash buffers and the lysis. So you just slot it in with the pipette tips, and then it takes the reagent and extracts within 30 minutes. And then for real-time PCR, which this system uses with probes, we are able to see your samples and amplify in real time. And with this system, you need some, for viral loads, you need to do standards to be able to estimate the quantity of your targets in your known sample. Well, that is the DPCR, which uses the micro changes, presence and absence kind of technique. So it doesn't use standards. It's actually detects, it's very sensitive, detects very low concentration, low target, detects low targets, and is actually like a senior brother to the qPCR. Uchenna was able to show us the difference between the QS5, the qPCR system, and the digital PCR system. And then behind you is our genetic analyzer, which most people know it for standard sequencing. So, but we are using ours for STR analysis, that's for paternity test. So it uses, it's just a capillary electrophoresis actually. So as the solutions that Thermo provided for paternity test, we can do direct amplification, so we don't need to do extraction of DNA anymore. Some of the kits that they have provided, we just do direct amplification, and we're able to just run capillary electrophoresis, reducing the turnaround time for results, and able to us to analyze also in real time and deliver results in real time as well. Prof, do you want to see?
Okay, sorry. Right, as my colleagues explained to us, that is our genetic analyzer for pharma analysis. The building by the side, will house our NGS, because we are trying to remodel the building to suit, but my equipment is already in-house, and we just finished with we just had the visit of Anna. So they came for accreditation. We have actually powered this instrument. I'm happy to tell you that this is where I really realized that my children were mine. Use on this equipment. By doing my own. No, it created a lot of problem between my wife and I. No, you know, this problem, you don't like it. So why do you want to do it? Why must you be now? I said,
No, don't you trust myself. So, actually, we did it here, and it really came out good. But unfortunately for us, shortly after we finished the analysis, because we needed to send the sample for interlaboratory comparison to US, to LabCorp, which result will come, which is very fantastic. So that means the run here was actually perfect. So light made us to lose one of the two. So it has come. Yeah, the power source, yes. It has come. So we are just waiting for them to fix it maybe this week. So obviously, when we address all these non-conformities, we'll get our certification for human identification. So she rightly explained the digital PCR. At the back, we are relocating it because we work in consonance with the NGS for oncology studies. So that's the little one we do here, sir.